Hello, everybody.
Hey, good morning, Mr. Bird.
How are you?
Hey, I'm doing great.
Yeah, you look great. Can you believe it's the end of the week already?
No, they seem to be flying by quicker and quicker, don't they?
Oh man, I know. I can't believe in just a little over a week it's Thanksgiving. Mm.
Yeah. Just one more week of classes too after today.
I know this is actually I'm gonna mention this when we get our quorum set up. This is our last lecture.
Oh yeah, yeah, it is.
I don't know who's more excited, you guys or me. Let me see here. We're getting close to the quorum. Hey, Armin, are you on the line?
Yes, sir.
Oh, great. Could you and Ibrahim set up a time early next week for us to test drive uh, uh, having the class set up their presentations? I don't think it'll take that long, but I just want to make sure that we dry run it to make sure it works.
Yes, sir.
Thank you so much.
Yeah, just with us or?
Yeah, just us. We'll figure out how we can try it out so that a week from today that we can at least be hopeful we don't run into any hiccups.
Yes, sir.
Thank you. So does anybody have any questions on anything? Final project, presentation? COVID, presidential polls, the weather.
Good morning, Dr. Berg.
Yeah. Hey, Lucas.
Is there a place you'd like us to submit our presentations so that they can all be consolidated into one, or?
That is a good question. Why don't I set up a site, and I'll write that down. Yeah, that's a good question. It'll probably be a OneDrive site. Does everybody use OneDrive? Does anybody use OneDrive? Yeah, Rob does. So I'll use the class email roster and send a OneDrive out to everybody and invite you in. The other option is a Google Drive. And at the end of the class, I'm gonna go over just a little bit on the slide setup. You can do anything you want, but this is just what we've done in the past, which might be helpful or not. So I'll wait a minute or two and see if anybody else pops up. Ah, somebody did.
I'm on the phone.
That's our new lecturer came online. In case you wonder why I look up sometimes, I actually have a bank of screens and then a second bank of screens. So when I look up, I'm looking at that upper bank of screens. Not that you care.
You just want to see where the baby noises were coming from?
Yeah.
Yeah.
So let's go ahead and get going. So we're going to breeze, I actually was unsure how to proceed today. We have a hunk of stuff to go to, and I didn't know whether we should just put our nose to the grindstone and power through it and have, force feed you the stuff, or whether we should take a more leisurely approach and walk through it. And I decided on the latter rather than the former. While the stuff's really important, I always get myself into the situation at the end of the semester where I spend too much time. It seems like I spend too much time on the front end and not enough on the back end. And chapters 6, 7, and 8 in particular are some of the core elements of what we do in design of experiments, which is, how do we screen all these factors that we might want to work on? And it's not unusual to get 15 or 20 different factors that you want to look at, and you don't know which ones are important. And it's these kinds of approaches that do that. But nonetheless, so if we're going through, if you have any more detailed questions, we can do that. We can go into that. But what I'm going to try to do is go over the remainder of 7 and 8. If we have time, and then go over one of the things I promised you all is to go over some of the non-parametric assessments, which is really not DOE, it's more statistics, but it's an important consideration, I think, for what you might do in the future when you're looking at data, because you don't know as managers what kind of data you're going to get, or doing this kind of work, what kind of data you're going to get. And I will guarantee you, I will bet you a paycheck you're going to get data that doesn't fall within the normal distribution. So you're left thinking, well, why do I care about that, and what do I do with it? And so we'll touch on that. And then if we have time, we'll go over response curves. And then I want to spend like the last 5 or 10 minutes just going over what we're going to do next week, which is, I was just chatting earlier that you're at the beginning of the semester, you don't think you'll ever get to the end of the semester. Now that we're at the end of the semester, we're only a week away from Thanksgiving. It's like, oh my Lord, how did that happen so quick? So here we are. So just to revisit where we were talking about to the K experiments, right? And this is one way that you streamline things. And there's, within 2 to the K experiments, you can do blocking. And remember that we do blocking because very often we have these things that we can't control, but they do impact what we're doing, and they're called nuisance variables. And you might remember also that we sometimes do replicated designs, which is we do the design over and over again to help us get a more detailed understanding of where the error might be in our experimental approach. But we also very often have unreplicated designs where, for one reason or another, and I think mostly your projects, you don't have, I'm just guessing, you have unreplicated designs. You've only done the experiment once, the set of experiments once. You haven't duplicated, you've done it once. So how do you do blocking in each one of those? And I'm not going to go over why we care about blocking, because we've done that before. So the easiest is a replicated design, and that's where we've run the sets of experiments multiple times, 2 to 3, 4, 5, 8 different times. And what we do with that is we take each replicate and we treat it as the block. So for say we've replicated 4 times, when we do our analysis, probably in fit model, but not necessarily, but probably fit model, we just enter whichever factor we're treating as the column that we have the replicate, and use that as our block. And so going into, I should pull it up. So this is the example out of the book, and if I remember right, we did it last week. Let's see, yeah, so this is it. So just to give you the example, so this would have said replicate number up here, right? And so these are our two factors. This is our dependent variable. And we just treat this column where it's each one of the runs, sets of experiments that we've done, we treat that as a block. Pretty straightforward. That's what this is. And they've done the analysis. And here we see that A and B are significant. A and B are significant here. But it turns out that in this particular case, AB is not significant. And it turns out, and you can't really see it here, but in this particular case, blocking really wasn't important. It didn't give us the p-value for some reason, or at least in the book there wasn't the p-value. But blocks was not a significant thing. But at the end of the day, what you got to remember is when you set up your experiment, then your repeats, if you don't build blocking into it and you do your experiments, it's really hard to go back and try to pull some sort of blocking out of it. It's much better if you have any belief at all, any hunch that blocking will might play a role, go ahead and do it. It'll save you a lot of work later on. And so you can impress your staff and bosses if you just ask a question. So did you consider blocking and how did you do it? You know, it's sort of like asking, why did you use student T as opposed to Tukey's test? You know, that sets them back on their heels, like they might know what they're talking about. I don't know if I can gaslight these people. So some of the other things. So if we just pull up, let me pull it up. So this is it in how the model is constructed. And so I ran it a couple of different ways. And one was the question of should concentration be nominal? Remember, we had this ongoing debate whether our variable should be numerical continuous or should it be some sort of categorical like nominal or ordinal. And it's the lawyer's answer again. It depends, right? It depends on, for concentration in this case, you know, its values 1 and 2. And so all those values, just those independent values on the knob that you're turning, so it's like red, yellow, or are they actual numerical values? Could it be that there's a 1.5 in between 1 and 2? That's the question. And so here they have it set up as some sort of categorical. What I did here is I ran it as nominal, and here you can see that blocks, if you look down the tiny number down here.
Dr. Burke, is it okay that it doesn't have numerical in it?
Yeah, so to your question, so tell me if I answered it. So if we switch this to continuous and reran this, that's am I answering your question? And then if we run it,
I guess I was going more toward the little experiment that I was doing.
no, it's how you set it up,
Right.
and this. So some of the backstory on this is the 1 and 2 are actually 1 pounds and 2 pounds of material that this experiment added in as a, we call it a catalyst. It's really more like a wetting agent or an alloying material. And so in fact, you could have, maybe should have added it as I would argue, as a numerical value. And so what I've done before is say, well, and in fact, one of the projects was going through that, and the analysis might be different if it's categorical versus numerical. Especially if you have no other numerical values, because then then you end up doing chi-square sorts of things as opposed to the regular analysis. We haven't talked anything about chi-square analysis, but if our yield was, say, a categorical, so you say this was hues and this was tints, okay? I don't know anything about colors. And this was the final color. Well, we'll say that there's no numerical value for a color, so you end up with 3 categorical factors. Well, how the heck do you analyze that? Well, we'll go back to how you build your model. Is that what I want? No, let's do this. Yeah, here. So recall here, it gives you this nice little matrix that says, well, if you have categorical and categorical, which is down here, it gives you continuous. You can still analyze it, but it does it based on the frequency of what happens versus what your model says would have happened. We haven't talked about 2 categorical or all categorical factors or variables at all. It's not because they don't happen, it's just that we haven't. And most of our analysis will be where your Y response is numerical and your X factors are either categorical or numerical. Recall, that's what gives us our ANOVA, right? You've got to have one numerical and then categorical at the bottom. You can do logistic, you can do one way. Maybe that will be one of your suggestions for future courses, future course. Which, by the way, I'll give you another reminder. Pretty soon you're going to be getting an email that says, please evaluate the course. Please evaluate the course. I don't see any of the results. So it comes out after final grades, so I can't even guess who it is. But please evaluate. And I'm going to spend some time at the end of this, I think, or next week, just soliciting what insights you might, candid insights you might have. And so this part was okay, but really didn't like this part. And I'm guessing one of the parts you really didn't like were the on-Canvas quizzes, because I didn't like them either. And then other parts, maybe like the breaks, recess, you liked a whole lot more. So anyway, so going back to this, so like I said, blocks didn't count for much. Didn't make no difference in this particular case that it was nominal or numerical. Turns out that when we did, if you reran it and did an interaction, that didn't make any difference either. And this last one is, if you remember the random effects where we treated
This morning
blocks,
they're wrapping the bean.
Okay.
Hmm?
Going good?
They had just started.
Okay. That's great.
Yeah. Trim
Wait,
carpenters are there.
those beans are just staying.
so you might want to mute
Don't
unless
say
you want
that.
to share some more.
Yeah, ask Jeff. What's going on?
So anyway, this is the random effects that we did. I think last week we started talking at least about confounding, which is I think a term that like blocking is a little bit doesn't really reflect what you're doing, but it's a term of art in design of experiments. I think it really is more like masking or morphing, because what you do is well, I mean, we'll go to this example and that'll explain it, because what you do is you take some of the information you have and you extract that out and you replace other information with it. Well, what do I mean by that? So let's run through an example. So Black Friday is about to happen in 2 weeks, right? Actually, kind of happening now. And all of a sudden you get this email that says, hey, we want you to do this experiment for us. We want you to help us understand what the best way to do advertising is. And we have 4 factors. We have the kind of promotion that it is, the kind of message that we're going to have in there. You know, so is it designed for millennials or whatever Z generation, or another group, and then price, low or high, right? So we have those 3, and then we also have 2 other factors: is it Apple or Android? But here's a catch: you can only do 8. You can only do 8 runs. So how do you get 8 runs out of 4 factors? Because 4 factors is 2 times 2 is 4 times 2 is 8 times 2 is 16. So really, if you do the full factorial, that would be 16 runs. But they say we don't have time and money for 8 runs. How are you going to do it? Well, if you had 8 runs, 2 times 2 times 2, and then you did one other, did the combination ABC, that would be information you have. So in essence, what you do is you want to consider all of the information that you have, but you're going to do it in an abbreviated way. And so what we're going to do, and remember we had that video last week that talked about confounding? Maybe not. What we're going to do is do A and B and C. Then our ABC is this, right? This is what Jump came up with us when we ran it. But we're smarter than this. And so what we're going to do is we're going to take this ABC column, and because we know that the higher factors usually aren't statistically significant. Your statistical significance, as we've seen, almost always, but not always, is your main factors. Not always. Sometimes the 2-factor interactions, and maybe 5% of the time or so, higher order factors. So you might on occasion get 3 factors. I've never seen 4 factors in the stuff that I've done. Not to say it won't happen. I'm sure it does happen, but you think about what it's going to take for 4 factors to actually interact. That's a lot of chemistry going on. That's a lot of stuff going on behind the scenes that can be very hard to tease out and understand what that is. And so what we're going to do is take this 3-level interaction and say, since almost always that's not representative, what we're going to do is change the title on this from ABC. We're just going to call it D, and D is going to be our which phone we're going to use. And so quite literally, we just change the title and put the data in there, but we keep the plus and minuses the same. I can't tell you how long I struggled with understanding this, and it's really that simple. All we're doing is taking out, in this case, the interactions and how Jump set up the experiment for us, and we're redefining it as something else. And what does that do for us? Well, it does a couple things. One is is by its structure, it keeps all of this random. We really want random, right? That's one of the key factors in any of our experiments is we want to keep it random. And it keeps our number of runs smaller. What do we lose by it? Well, what if there were an ABC interaction? What if that was the case and we didn't test for that? Well, we lose that information. And so that's a trade-off that we're making is we're saying we're not going to do the ABC interaction. We're going to stick either Android or Apple in each one of these experiments because we think that's more important to us. We want to get that information. And it's that simple. Any questions on that?
So when I look at that, it with the 3, it tends to always land toward the one that is either the least. So like in number 2 for run 2 it ends up being the Apple, right? But you have B and C that would, I guess, outrank it by both of them being the Android with a single for the Apple on A. So why does that single response versus the dual response for the others rule out?
Can you ask that question? I'm not sure.
I'm not sure how to ask the question. I'll be honest with you.
Okay.
Because the pluses and minuses kind of throw me off. Maybe that's what you were talking about. You had difficulty too. But
So think of this as plus or minus is low or high. So, or 2 different types of, so we have a promotion that's, say newspaper or radio. So promotion is newspaper or radio. Message might be like a car salesman and is just blasting at you, or it might be very subtle. All right. So we'll say loud or subtle. Price would be low. So minus would be low and price would be high. And then Android would be minus and plus would be Apple. So it's not necessarily, it's just, so we have 2 levels in each factor. The level being 2 settings. So if you think of A, B, C, and D as settings, you know, we have, so I'm pointing at the screen here. So, yeah. So here is setting A, here is setting B, setting A. Oh, what terrible. And
oh, you got it.
I don't want to use A and B. So this would be setting 1, setting 2, setting 1, setting 2 for this particular factor.
Sure.
All right. And then all we're doing, so this would be normally this interaction would be A, B, and C. So in this particular case, it would be 1, 1, 1. If we kept it 1, if we kept it as ABC, we're saying I don't give a crap about ABC. I don't think that interaction is going to be worth my time. So instead, I'm taking out ABC. I'm getting rid of it. And I'm going to put my D in there. And so now I've got a way to stick in my Android and Apple and maintain that fewer number of runs. Did I answer the question?
Yeah, but how do you discern what D is? How do you determine that?
You lose. You mean B here? You lose it.
Okay.
I'm just literally changing. I'm keeping this.
Sure.
And I'm saying, I'm not going to do ABC here anymore. I'm inserting a new factor into this.
Okay, I got you. I'm with you. That
Completely
makes
inserting
sense.
a new factor. So if you think, yeah, so I'm assuming I don't need A, B, and C. I'm assuming in this approach that all I want is a primary factors. I'm not doing this interaction. And so I'm taking out this A, B, and C and sticking in D.
Uh-huh. Yeah.
And the reason that is called confounding is that at this point, then I don't know about ABC anymore. So I'm eliminating ABC and putting in D. So I lose that knowledge of A, B, and C. That's why I don't like the term confounding, because I think confounding means confusing, and like repeats in JMP, confounding is used a couple different ways. So I'm going to confuse you even more in a couple of slides on what confounding is. Because,
That's pretty descriptive for me, because that was confusing right there, but
yeah. So we're just replacing it. We're saying, I don't care, and we're just replacing it. Good question.
thanks.
All right. So what we did here, confounding, is what we do on unreplicated blocks. So remember, unreplicated blocks, we just ran everything just once, right? Which is exactly what we did with this experiment. We could have said, well, you know what? I'm going to run this 5 different times, this promotion. I'm going to do it in 5 major cities. And based on those repeats, I'll block on that, right? So I have 1, 2, 3, 4, 5. And I'll say those are my blocks. Could have. We didn't do that here. We only ran it once, and that was an unreplicated block. And so what we do is unreplicated blocks is we use that same process, and it doesn't matter how many factors you have. In fact, really, the more factors you have, the less concern you have of losing information, because you normally use the higher level interactions where you really have much less of a chance of getting meaningful, statistically significant information out of it, and use those. So one of the terms I use is usurp it. So you actually take that spot, you take that column and use it for a different purpose. Forgot that I said that. And the trick is which column to use. So if you remember in one of our earlier examples, we really did have a 3-factor interaction that said that it was statistically significant. And I forget, it was one of the examples, can't remember which one. So what if we would have used the rule of thumb and said 3-factor interactions normally don't have any statistical significance, and we use that? Well, our loss, right? It happens. So that's why the trick is to figure out, and why you do screening sorts of experiments to see that. And so this is information that Montgomery provides us, and he uses his blocks, and what we're looking at are the main effects, and we've done the experiment, and we see what the percent contribution is, and we can see that those higher interactions tend to be lower, and that as he blocked it. And so what we did in this was we took out the 4-factor interaction and replaced it with the data that we wanted. And the block here contributed 19.51%. Recall that this is really a percentage of the sum of squares. So you add up the sum of squares and divide by this number. In this case, it's a little over 19%. So same process. So that was just a more factors to look at, and kind of a visual way to represent that.
Is that something that we would need to apply in our projects, or is that just a representation of how the software communicates and calculates the effects of confounding?
Yes.
Well,
So if for example, so yes to the question about the software, and the software, most softwares that I'm familiar, I'll say all softwares, use those main effects to do the calculations and to figure out, and we'll get to this in looking at fractional factorial here. So great leading question, Mia. So that's it uses the primary factors and those kinds of calculations to figure out how it's going to build your fractional factorial. Saying in a different way, it's going to figure out which things it's going to extract for you so that you have fewer factors to consider and run as part of your experiment. When it comes to your project, you can use fractional factorial. So if you had, say, 5 factors and wanted to explore which of these factors, how do I say it? 5 factors was too much for you to run all experiments because that's 2 to the 5th, right? So if you had two levels, and this is all 2-level stuff, right? So it's all factors with a low and a high, or a red and a green, or a plus and a minus. It's not like Lucas, this was yours where you had multiple levels, right? I think. I remember that right? I think.
Yes, that's correct.
Yeah. So Lucas was ambitious and decided that he was going to have multiple factor levels, which is great, perfectly fine. It's okay to have 2 factor levels. All this is for 2 factor levels. So Mia, direct answer to your question. You can, but you don't have to. And so if you had 5 factors and said, I don't want to have to do 2 to the 5th runs, you could do a fractional factorial or this sort of thing and say, I'm going to do 2 to the 4 or 2 to the 3 runs. I'm going to do 8 runs, and that's going to be my screening work. Or if you wanted to just say, hey, I explored it just to see what's going on, and this is the table that it gave me, but it was easy for me to do 2 to the 8th, so I did. Did I address that for you, Mia?
Kinda. So what, so what I'm thinking is we have our data,
Mhm.
and I think I get it. I think I get what you're saying, because in our setup we have to tell the software what level of interactions we want. I guess I'm trying to relate this to JMP, where we're in, designing our experiment.
And I'll answer it now, and then we'll come back to it. So in JMP, it would be, so I'm just going to go through this really quick because I think it's answering your question. Ooh, yeah, we'll leave it. I don't want to do that. Okay, so this is the tool in JMP, right? And so we're going to have 12 2-factor interactions, and they're all categorical. And then in JMP, it asks you, so how do you want to do this? Do you want to choose from a list, or do you just want me to use the main factors? So we're saying you're going to choose from a list, and it gives you this list. And so it says, how many runs do you want to do? And it gives us all these flavors of different kinds of runs to do. And so you're a minimalist, and you say, and there's 12, right? So whatever 2 to the 12 is, it's a big number. That's a huge number. And it says, hey, I can do 16 for you. And it's main effects only. And if we click this, and I'll wait till later to click it, it'll build you a table that designs your experiment for you, hence the name of the course, designs your experiment for you, and you basically plug it in and run the experiment. Depending on where you are in your project, if if you had three factors, you really don't have to do fractional factorial unless you want to, right? Because that's the whole idea behind the project. You kind of show what it is that you want to do. Or 2 to the 3 is 8, so you have to do 8 different experiments in order to get that full factorial. So depending on the number, I'm not trying to be evasive, but so what you could do is say, I've got 4 factors and I just wanted to explore what a fractional factorial might be. And so I built this table, and here's what it was, but I made the decision that running the 4 factors at 2 levels, say you had 2 levels, it's straightforward to do, and it gave me the more robust answer. The risk of running fractional factorial is that you lose some insight, you lose some granularity of what you're doing, but you got to remember, here, what is 2 to the 12th? It's not 128. Hang on. Somebody racing me to do this? 4,100. So it's 4,096. So you'd have to do, if you had 2 to the 12th, if you do a full factorial, you have to do 4,096 experiments.
I think I get it.
Yeah, that's, yeah. All right, I'll be quiet.
Thank you.
Okay. So oftentimes we try to reduce the number. You can also, depending on the approach, there's multiple approaches of fractional factorials. You can use it to optimize. Some of the designs will allow you to look at nonlinear relationships. We'll talk a little bit about that. So there's, in fractional factorial, there are 3 things that you think about. One is what we call the sparsity of effects. And it's what I've been ranting on for the last while, 43 minutes. And that's where, it's the 80-20 rule, where there's, of a bunch of factors, there's only a small handful that really tend to contribute to overall statistical significance. There's a projection property, which is basically when you use fractional factorial, you can envision, you can extrapolate to the overall model set, because it amounts to building your sample population. So you have an entire population, and what you do in statistics is you very often can't sample the entire population, right? And so you have a gazillion COVID patients, but you can't do tests on the entire population of gazillions. So you pick 120. And you say that reflects the overall population. That's what you do. That's what projection property is so your design reflects the overall full factorial design. And then the other is sequential experimentation. So you can actually combine these to get a more robust insight into what you're doing. And so with Mia's question that I probably answered more to than she really cared about, or maybe I didn't answer it along, but I needed to stop. The number gets really big really fast because it grows exponentially, right? there's a degree of freedom issue too that we have to be aware of, because if you remember last week, I think we ran into that. If you run the full factorial, you run out of degrees of freedom, and so you can't run the experiment, and so you got to start yanking out some of the things that don't count as much in order to actually get the model to run for you. And this is what we talked about here. You know, so 4,100 if you have if you have 12 factors. So I was going to talk about balanced and orthogonal, and it's a little bit of matrix math. What it's really saying is that you need the same number of factors, and it needs to have a representation that you have the same number of highs and lows in their in the model in the same way. And so let me just go down. And so if you look at this, you know, you have the same number of plus and minuses up and down and across. And that's really what orthogonal means. And so I think I have a slide that talks to that calculation someplace. I may have taken it out. Here it is. And so this is all orthogonality means. And so you take your matrix, and these could be ones and plus ones and minus ones. This is just a vector, you know, so it's the coefficients in front. And you can do this by hand. Jump does this for you, and it'll inherently build a balanced, you know, if you wanted to, balanced and orthogonal model. I haven't found it. I haven't needed to. There's probably a way to do it without that. I don't know why you do that, but it can. And so let me go over this, and then we'll take a quick break. So the terminology for fractional factorial, what we're taking is we're taking the 2 to the k designs and reducing that k exponent. And so the typical and most straightforward fractional factorial model is the 2 to the k minus 1 design, called the 1/2 fractional factorial. Well, where do they get 1/2 fractional factorial from? So if we say that we're going to do, oops, what happened? So say we're going to do a 2 to the 6 design. That would be 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So that would be 64. Did I get that right? 64. And this is equal to my k. That's an equal sign. So that k is, oh crap. Do that over. This k, that is that k, okay? So k is 6 in this case. So what happens if we did 2 to the k minus 1? That would be 2 to the 6 minus 1. That equals 5. So I told you the math in this course was not hard. 2 to the 6 minus 1 is 5, right? Well, what's 2 to the 5th? 32, which is that magic number 1/2 of 64. Hence 1/2 fractional factorial. All right. And so In this, we have a 2 to the third, and that means that we have, so 2 to the third is 8, right? So 1/2 fractional factorial is the exponent 3 minus 1 is 2, so that would be 4, right? So we have four factors, or four factors that we're going to consider at any one time. And here's how that looks. And we have A, B, C, and A, B, C, A, B, C, and should be, and then A, B, C. That goes over there. And this is our buddy Montgomery, how he likes demonstrating with cubes. All right. And so this gets back to that whole issue of confounding. And some people use the term aliasing and confounding interchangeably. A more accurate term is aliasing. So what we're doing with this and at some point, Mia is going to ask me, why in the world are you making us go through all this when JMP's just going to do it for us automatically? And I'm going to say, because I can't help it. So if we look at a full factorial design of 2 to the 4th, right? Because that's what we're talking about, or 2 to the second. And that comes from the 3 minus 1, which is equal to our k, which goes to 2 to the 4th. So here's our, this is our 2. Here. So we have AB and AB. And what we're going to do is substitute. So we're saying we're doing 2 to the 4th. So here's our 2 to the 4th example. And we're going to add one more in, which is our C. And all we're doing, again, is taking what would happen with C and usurping it and replacing it. So that's simply what we're doing. All right. So now is a good time to take a break. We're going to go back and jump into using JMP for setting up for a fractional factorial. So let's take 10 minutes. Let's get back at 10. Let's get back at 10. So is everybody back? Is everybody that wants to be back? Okay, so where we left off was we're going to use jump to build that table that we very quickly went through in answering Mia's question. So how do you build this thing? How do we use a power jump to help rescue us from having to try to figure out how to do this by hand? You can build these things by hand, by the way. And there's a big table somewhere in your book. I can't remember, it's chapters 8, 7. Has anybody looked at the book other than to do the problems? I don't know where it is in here. Montgomery put a bunch of information in there that basically are lookup tables on how you can construct fractional factorials. It's kind of like using a slide rule these days. And I think y'all are been around long enough to know what a slide rule is. So let's just go here. And we'll go to DOE. Oh, better idea. That. And so we simply follow these instructions, right? We go to DOE, classical design, 2-level screen, screen design. And we get this. So move this out of the way. And we'll pull this down and just see what it tells us to do. So we're going to add 3 factors that here we're saying categorical. And recall that all these designs are 2-level designs. So we'll type 3 in this little window here. And then I said they were categorical. I don't know why, because I think in the example they're actually something different from that. So it says for us to go here, choose from a list of fractional factorials, and we could do a full factorial, fractional factorial. So we'll just do a fractional factorial, make the table. And this is the table that it constructs for us. And so if you actually drew out what a 3-factor full factorial would be, well, we could do that. Let's do that real quick. Back. Continue. Full factorial. Continue. Table. So that's a full factorial. And to compare it to our fractional factorial, if you walk through this, you'd see that what we've done is extracted out some of the factors. And that's what JMP does for us, and what the table's hidden somewhere in the bowels of Montgomerysburg has us do. And so if you were to want to do this, say each one of these runs is $100,000, obviously you'd want to minimize the number of runs that you'd want to do. And so whatever factor one is, you do your level 2, level 1, and put your answer here. And same here, and same here. And this pattern is just another way to symbolize what this is. And so, as we were discussing earlier, plus is level 2 here, minus is level 1. So if it's categorical, the level 2 could be red, this could be yellow. This could be red, this could be yellow. So this is 1, so say these are colors. This could, say it's eye color, so it wouldn't be yellow. So blue or not blue, right? Blue or not blue. Doesn't matter which one you set it to, it's just blue or not blue. And this would be another categorical. Say it's fingernail type, ridged or not ridged. We're doing genetics today. And this would be another categorical value. Say it's complexion type, right? And you simply run the experiment at that point. That's how easy it is. And so this shows us the same thing, where we use 4 factors instead of 3 factors. Set it up in JMP. For some reason, this version of JMP, this was a little, I didn't update this. The categorical had pluses and minuses. Getting back to Joe's question earlier, I think that was one of his questions.
It was.
Yeah. So this this has us go ahead and make the table again. So if the reason this is in here is if we wanted to get the same results, because each one of those results will be different, right? Because it's all generated randomly. And I'll refresh your memory about the random seed. You go in if and this is a good practice for any kind of modeling. So if you go back to the modeling course that you had where I think it was systems dynamics using AnyLogic. In there is a setting for the seed, and if you all had the same seed setting, you all get the same results. It's just the way that software works. I'll talk a little bit about this thing called design resolution. First, I'm going to get some coffee. So this thing called resolution is how much is being extracted out of your model. So what is the granularity or fidelity or how much aliasing or confounding goes on within the model. And this table you'll see in many different places on how the models are structured and the resolution of the models. And if you look at your book, they'll talk about resolution 3, resolution 4, resolution 5 kinds of models. So working down a level 3 design is, so if we take a level 3 design, the main effects are aliased with the 2 factors, and that's called the 3. So if you look at a level 3 design, so come on. All right. So you look here, and you look here. We look at a level 3 design, and we're doing a half factor design, which remember is 3 minus 1. That's 4 runs. That's a level 3 design. And what we're aliasing are the main effects with the 2 factor interactions. So remember what aliasing is? We're slamming them together, and we're replacing the 2 factor interactions with some of the other interactions. A resolution 4 design, so let's find a right here is a, yeah, right here is a resolution 4 design. 2 factor designs are aliased with other 2 factor designs. In a resolution 5, 2 factor designs are 2 factor interactions, rather, are aliased with 3 factor interactions. This, when you start getting models this big, these are really big models. You'll typically see this sort of thing here. So that's when people start talking about resolution levels and design, this is what they're talking about. So we're going to do an in-class exercise here. You're going to do an in-class exercise here. And what we're going to do is, what you're going to do is pull up this data table, and you are going to do the analysis for me. And so I'm going to give you 5-ish minutes to try to run this. And so you'll find this in modules. So if you go to Canvas, I dumped it onto there. It's in module 6 somewhere in all files that are there. Let's see if I can find it.
It's the last one in module.
Is it the last one in the module? Thanks. So you guys run that. I will run it. And we'll see what we come up with. Tally ho. Do you want some background music? No? How are we doing? Crickets. Y'all ready to explore this? Yep.
Yeah.
All right, simple enough, right? So it's already set up for you. And let's first look at what it's got. So it's got all continuous variables. All right. But by the way, just kind of as perspective, this is looking at extrusion, right? So this is an example out of the book. It's looking at chapter 8. It's looking at extrusion and looking at shrinkage as a function of these sorts of things. And so it it built a series of two-factor interactions. But before we do this, did anybody plot out to see if it was what the distribution looked like? So let's look at that. Always the first step, graphic, always the first step. If you're reviewing anybody's data, if they don't show you the graph, the very first thing, send them back out, make them come back with a graph. So here it is. Now, first thing I see there is that, well, first thing is how much data do you have? Well, you have 16, right? So it's not a huge data set. And so whatever, when we get smaller numbers like that, you know, certainly less than 20, less than 30, because remember 30 is kind of that rule of thumb where it's above 30, then the whole idea of normal distribution kind of takes care of itself, because and there's been studies on this, that 30 is that sweet spot where the law of large numbers takes over and you worry less about normal distribution. So do we have a normal distribution here? Well, let's look. So we'll do a normal quantile plot. We'll at least try to do a normal quantile plot. And, you know, it looks a little bit, I mean, it looks good. So it's within these confidence intervals, but we have this interesting way that the data goes, where it sweeps down, then it goes up, and then it has this kind of curve. So this is a little bit of a trick. Whenever you have that kind of curve, I found in my experience, so this is going like this, and then you get this line. Sometimes you'll see it go like this. That's that's an indication to me that this might not be a normal distribution, although it falls within these lines. So we'll do some of our other things. So we can, so we've looked at the plot. We can look at continuous fit, normal. Diagnostic plots, remember these diagnostic plots? So you do the QQ. This looks exactly the same as the other one. And then I think I showed you this once or twice, where we do goodness of fit. And the goodness of fit are a couple of tests, these two tests here, that say they test, does the data represent normality based on, so they plot this hypothetical curve and lay this data over the top of it. And, you know, the alpha here is 0.05. And so this is below 0.05, right? And so what this says is, based on these tests, not so normal, which is what we saw up here. You know, it's a little bit skewed to one side. Well, what do we do with that? Well, we'll talk about that in about 7 slides. But I'll again caution you that we only have 16 data elements here. So it might very well be normal, but this data is just not showing that it's normal. So we go ahead and run this. So did you all get something that looked like this, I hope? Right? So all I would do is press run. And we see this. So what does that mean? So I didn't really give you enough time. But did anybody look that up? So let's look that up. So I spent a lot of time doing this sort of thing. So it's called singularity. Oops, sorry. This cursor is having too many screens. Ah. So the second thing you don't like is when Bert tries pulling screens over from multiple screens. Singularity detail. There it is. Let's see what it says. All right, singularity details. So a bunch of mathy stuff that's gobbledygook, doesn't make a whole lot of sense, except this right here. The terms involved in these linear dependencies are alias confounded. So here's where they're using that term alias and confounding together. So you can look at this, put it on your reading list over Christmas break. All it says is the matrix math that they're doing here and the way they have this set up. They're telling us that these are the factors that are confounded. That's what it's saying. So thank you to JMP for saying that. Look, these two interactions have confounded each other, the alias. So we can't tell the difference between the two. So the temperature by gate and screw by hold time, they overlapped each other. So we got that in there. We just can't tell which is which. That's what it says. And we can look now at the p-values, and we see that the p-values here we have 3 that are statistically significant. Hang on a second. And none of them are confounded, it seems. So we have temperature and gate and screw and hold time. But at least those that are statistically significant aren't confounded. So that means we don't have to worry. So temperature and gate and screw and hold time. So JMP was smart enough to look at this and say, the 2 things that are the lowest, I'm going to overlap and reduce your model set for you. Let's keep going. So the studentized residuals look pretty good. And then we look at the effects. And if we wanted to, we could see what the effects are, right? So this the analysis is the same as what we would have done before, except the understanding of this interactions. And if you were to do additional analysis, depending on what you do, I was doing that earlier. Oh, here. It gives you an alert that some of these things were dropped because of this. It means what I'm saying is I can't tell you what's going on with that because they're alias together. And so I don't have enough. We lost that detail on those 2 elements. All right, thank you, appreciate that. And here's that normal plot. And I like half normal plot because it's easier for me to read. And it says, these 3, maybe 4 things are the things that ultimately you care the most about. So out of all those things you ran, and you did fractional factorial, which means that you ran even fewer interactions and those sorts of things, those 3 to 4 things are the things that you care most about and what you do your additional experiments on, which is what fractional factorial does for you. So it allows you to do that screening to find the most important things. So how'd you all do except for the singularity? Were you able to decipher that? No? Yes? Okay. So this is an actual experiment. Whoop, I'm going to do that. That I pulled up that somebody would. I don't know what just happened. That was an actual experiment wherever it went. All right, here we go. That somebody did on driving and effects on driving. So all those sorts of things that might affect driving. So there's 34 different factors. And let's just say they're two-factor interactions. So that's 2 to the 34th. Clearly, you want to reduce that. So one of the approaches is this thing called Plackett-Berman. And I'm going to run you a quick video from our buddy that we saw last week.
Hello, I'm Ray Sheen.
Hi,
I'd like
Ray.
to discuss a special case of fractional factorial DOEs known as Plackett-Berman. You may be wondering, what is a Plackett-Berman DOE? Well, it's a very effective fractional factorial DOE that can analyze dozens of factors with very few runs. It's named after the gentleman who developed the approach, Robin Plackett and J.P. Berman. They created the methodology way back in the 1940s, when all the calculations and setup had to be done by hand because there was no computers available to do it. In fact, their study was based upon an agricultural problem, where they wanted to understand what were the major effects on crop yield, and they had over 30 factors that they wanted to study. The key principle they applied, which earned them some ridicule from the mathematical gurus who were the gatekeepers of DOE at the time, was that they ignored the interaction effects. They only wanted to know what were the main effects. Frankly, that is an eminently practical question when working with agriculture in the 1940s. The mathematicians may find the coefficient for third-order effects highly interesting, but the farmer wants to know what are the top 4 or 5 things that they need to worry about each year. And that is why I love to use Plackett-Berman for screening studies, especially if I have lots of potential factors. It boils those down to the vital few that I need to concentrate on. I can then take these to a refining phase of my study. So how do we set up or design one of these studies? One thing to understand is that the number of experiments or runs will always be a factor of 4. Things like 8, 12, 16, 20, 24, and so on. The reason for this is that you need to have a multiple of 4s to have a balanced and orthogonal test matrix. The number of factors that can be analyzed is 1 less than the number of test runs. So 12 runs can analyze up to 11 factors, and 20 runs can analyze up to 19 factors. This approach does not come free, and the issue to recognize is that all of the interaction effects are confounded. You only have main effects, but that may be okay for screening phase. One thing that you have available to you that Plackett-Berman did not is Minitab. When you select Create Study Design from the DOE menu, you get this panel. Well, instead of using the first line, which is the default, select Plackett-Berman Design. Notice that you could have up to 47 factors with this approach. Next, select the number of factors that you have, and Minitab will create the matrix. This is the matrix for the 11-factor Plackett-Berman that I had selected on the previous slide. Notice one of the constraints is that you can only use 2-level factors, but that's what we normally do with screening phase anyways, so it really isn't a problem for us. And we have 12 runs, a number that is a factor of 4, and that means that the matrix is balanced and orthogonal. You can check the balance quickly by seeing that if you add all the columns, they total 0. Orthogonal will require you to multiply each of the columns together and then add the result. And I'll just leave that for you to do on your own time. Actually, easy. Let's wrap this up with a discussion of the pros and cons of using the Plackett-Berman approach to fractional factorial DOE. First, we must acknowledge that this is a special case DOE design and should only be used under certain conditions. That means we only use it in screening studies with 2-level factors. Typically, at this point, we're not worried about interaction effects, which is okay because Plackett-Berman won't give us those. And it only makes sense to use this when you have more than 4 factors, and usually a lot more than 4. If there are less than 4 factors, just do a full factorial DOE. Finally, if money or time is short, use this approach to at least understand the main effects. Which brings us to the advantage of using this approach. It's fast and cheap. The more factors you want to analyze, the more important this becomes. And we've already mentioned the downside, but let me quickly summarize. No interaction effects are identified. everything is treated like it's a main effect. And that means that if one of the true main effects is an interaction effect, it will be confounded with something else, which may not be at all important. That means you could wind up trying to analyze something in your refining study that is actually irrelevant. When you have lots of factors and you need to isolate down to a vital few, the Plackett-Berman fractional factorial DOE approach is the one that best fits that bill.
Okay, so this I got from this website. I was saying, Go Skills. They give you like a lot of these places. They give you a couple free samples, then you got to buy it. And I cheaped out after like 3 or 4 of them, but they do a reasonably good job at summarizing that. So that's my reference for that. So you don't say I'm plagiarizing. So let's see if we can highlight some of the things. So we can go in and do this, do a Plackett-Berman design. It's not too dissimilar from what we're doing before. I don't think I'm going to run through this in the interest of time. I'll leave it to you if you're interested in doing that. You can go back to the slide and literally pull these up. These all these data sets. I don't know if you've gone into JMP and explored those. I think we did it the very first day of class, where you go to help, sample data, and then most often they're in design of experiments, and you'll find all these here. And so if you're doing this sort of thing for work or have any other reason to do it, those are where the examples come from. I will mention as just a toolkit for you later on. You can get a whole slew of add-ons. I only got 2 here that JMP will allow you to put in there that will do all the calculations. So it's almost like the GitHub version of JMP, where you can create your own add-ins if you wanted to do something, or you can go and on the web and download a bunch of different ones. So I just have 2 calculating effect sizes, and then I forget where I found it, but in an older version. So we're at 10. So this is edition 8 is all of the data sets for that textbook, which is helpful for me because that's what I use. So this goes through that setup. One of the other specific fractional factorial designs are definitive designs. Also, you'll find in JMP as a just like you will Plackett-Berman definitive designs. This has some advantages and disadvantages over some of the other fractional factorial designs. It can do both categorical and continuous. Probably most importantly is it does interactions, where Plackett-Berman, remember, doesn't do interactions, but also it allows you to put in midpoints, so it'll do curvature. Why do you care about curvature? Well, remember, the universe isn't defined by straight lines, and you might have a knee in the curve, or a curve that you might have something that, so if you have 2 data points, it looks like that, right? What happens if your data really goes like this? So your assumption on a continuous or even categorical is that if it's like this, and then you have this point here, you're way off. It's like polling for the presidential election. Really missed those midpoints and got it largely wrong. And so this definitive design allows you to do those kinds of curvatures. The other is it allows you to do multiple order effects and allows you to do various runs and put them into blocks. It does all these kinds of things, allows you to go up higher levels of interactions if you think that's important for some reason, which is, I think, what happened in the project that I was working on at the same time as yours. I think there's other things going on, and I just couldn't tease those out and pull out the information that I need to. I just didn't have enough detail. Okay, let's see if I want to say anything else about definitive designs. You can be very efficient, just like you can with Plackett-Berman, not a whole lot. This is how you get there. So there's actually in DOE a definitive screening design, and you can model it being definitive screening design as part of it. Okay, one thing for some reason I never get to is response surface methods, which is a way to take what you've done and optimize it. And so it it allows you to, in a multi-space, so this is three-dimensional, figure out where the optimum highest or lowest, depending on what you're trying to do, combination is for your experimental run. So if you were trying to figure out best amount of vaccine to use, you'd use some sort of response surface method. And so you can do multiple orders, do all that sort of stuff. So that's what I'm going to cover on like the core design experiments. Now we talked about the non-normal data set. And one thing I talked about very early in the class is parametric versus non-parametric analysis. So you do non-parametric analysis when your underlying distribution is not normally distributed. Not normally distributed, like that data set was. Or you don't know what kind of distribution it is. So it's not normal, but you don't know, is it log normal? Is it a beta distribution? What is it? It's a small sample size. And so we know what a small sample size, usually something less than 30, could be 15, ours was 16. Very often, I think you all will have small sample sizes because it's so expensive to do the kind of detail you need. And if for some reason you want to test on median or some sort of rank order as opposed to mean. So these are those distributions, right? And if you spend any time looking at data, you'll begin seeing these sorts of things. So we have normally distributed, but then you can get those like our data set was in the earlier example where it leans to the left side, negative skew, it leans to the right side, positive skew. You look at here where there's smaller number of data points, beta distributions, which are I like a lot because it's a comprehensive review. They call it kind of the king of distributions because it can represent a combination of distributions all combined into one. So how do you decide whether or not you're going to use parametric or non-parametric? So you look at your data type. If it's categorical, you're left to one, not parametric. If it's numeric, you have two choices. If it's not normal, you do non-parametric. If it's normal and you have the variances are equal, then you can do parametric. If it's not non-parametric. Now, what I found really interesting is that so little time in statistics is spent teaching about non-parametric analysis. You look here and we only have one part of the chain that talks parametric and all the rest talk non-parametric. But really what makes it non-parametric, instead of use the mean, use something like the median. That's the difference. And here we're talking about the dependent variable that does not follow a normal distribution. And these are the kinds of tests that we use. And so we're going to do a real quick example and jump to look at this. We've got some data sets. Here's some other ones. So we have chi-square, Kruskal-Wallis, Wilcoxon, a median test, sign test, Fisher's exact. JUMP doesn't have all these, but it has most of them. Actually, I'm going to use a different. Am I going to do this example? Yeah, I'm going to do this example. I built another example too. Okay, profits is the response. So we go into pick companies, that's companies, analyze fit Y by X. So we're going to do fit Y by X. I think, did I say profits was the, profits. And then type. Ah, there it is, type. And we build it. Okay, what do you see? Well, one thing is we see what looks like an outlier here. What we didn't do, I'm just going to put this over here. What we didn't do is draw this out, right? So we're going to do that real quick. So we said profits. And it kind of looks like it's giving us a finger. So we do normal quantile. And remember that curve that I said before where it's got the up and then levels off? As maybe an indicator that it might not be normal. Well, we're seeing that same thing here, right? It comes up, levels off, and then this happens to swoop up. And up here we have that one data point that's hanging out. So if we were to do that normality test, which you do by coming down here to continuous fit normal, and then goodness of fit, we'll see that, wow, this is way below 0.05, saying that the data is not normal. And here we have 32 data points. And so it's a large enough data set where we should be able to recognize that this is not a normal distribution. And so we're going to come back here and we're going to do two things. First, let's compare the means. And not be concerned about normality. So we're going to run a Tukey test. And let's see here. Do our favorite connecting letters. And it says that, oh, these are both the same, right? So we have two A's and they're both the same. All right, that's good. Now, let's run a non-parametric. And we're just going to pick the Wilcoxon test. And look what look what the Wilcoxon test is telling us. It's telling us that these two things are not equal, that they're different. So understanding the underlying structure nature of the data shows us that while in one case, the Tukey test, the test that you use the normal distribution on showed us one thing, the distribution that we should have used in this particular case, because the data was not normal, showed it gave us a completely different result, right? Now we can do one thing. So what do we do about that? Is there a way that we can better understand what we're doing? And the answer is yes. So I'm going to go over to, and I'm going kind of fast here, and I apologize for that, but I want to at least show you this. One of the things that you can do, let's see if I can find it really quick. Trying to find it here. Oh, here it is you can transform the data. In what, oh, sorry, can't do it on this one. So let me show you on a different one. Transforming the data basically uses some math and changes that normal distribution to a straight line. Right here. And so these are three different plots I did to show you the different distributions. Tell you what, I'm not going to show you the transform because I want to get to two other things. So you all have to ask for a second course in design of experiments to get this. One is a semester project. I'm going to go over the slides on that. You can have as many slides as you want, but remember you have 5-ish minutes to go over this. And so you're only going to have time for a few slides. And my suggestion is that, excuse me, they all be graphics. They mostly be graphics. So you can have a table. You can have charts, graphs. Include a brief description, you know, sort of, so you have a cover slide, which name of your project is the name, a brief description of what you tried to accomplish. So, you know, I wanted to see if there's a difference between, I was working on understanding flight path of Nerf arrows. And my objective was to understand what the difference between high cost and low cost was, my hypothesis statement, my null hypothesis, my alternate hypothesis. Of course, null is the status quo, there's no difference, or there is a difference, or you could have 10 different hypothesis statements depending on the number of factors and what you're looking at. Slide 2 is the description of your design of experiment and the rationale for using that approach. So getting back to Mia's question, I decided to do a full factorial. I looked at partial factorial, didn't really have enough data for that, didn't figure I had enough factors to consider for that. I used multiple levels, and so I did this approach, all that kind of stuff. So we spent a whole semester going over this. And so, so that's what goes in there. How you collected your data, very important consideration. So set on 5 different factors, ran 16 different runs. Here's what my controls were. As important as it was, so issues and challenges and assumptions. Assumptions are really important. Issues and challenges. I don't care if you ended up with a good positive outcome or a negative outcome. That's what an experiment is for, is to show I ran this and got nothing definitive out of it. All right, that's a good result. Or I ran it and I proved that adding fertilizer helps grass grow. All right, that's fine. So how I designed the experiment and all the things that wrap around that, the data analysis. So going back to the previous, here's what my data analysis is. Include your graphs. Doesn't matter whether your data is normal or not. Matters how you analyze it and do you include that. If you had minimal factors, do that. Look for outliers. Explain your outliers. So if you have a data point that's like the other one and it's way up in the upper right-hand corner, that doesn't necessarily mean that it's not representative. It just means that there's a story behind that particular data point, and you need to consider that. And then issues and challenges, ranging from, boy, it was really hard, so I did the best I could, to, I couldn't collect all my data, and so I had missing data. And then basically what you ended up with. So results, what worked and what didn't, what you thought you did good from a design of experience point of view, and in hindsight, what you might have done differently. Because this is all about learning, right? So part of this is I'm considering all these more or less screening experiments. And now that you know that what you know, what might have been done differently? And that's it. So any questions on that? So we'll figure out how this is going to work in terms of presentation. I will set up that share drive. That was a good idea. I suggest you have your screen set up so we can screen share. We'll figure that out. Anything else? I'm sorry, this, especially the last like dozen slides went so fast. But I wanted to get through that, so at least you saw some of that information. All right. Well, I'll let you guys go with 4 minutes to spare. If you come up with any questions, shoot me an email. And you can have a break until your next lecture.
Hey, Tom.
Yeah.
Are the midterm grades going to be posted? You said they were going to go up last week and I never saw them.
All right, I'll check on that.
Thank you.
Yeah.
Hey, Tom.
Yeah.
So when can you, how do you want to set something up? If I had a question about my exam or my project, my semester project.
Just shoot me an email and we'll find a time.
Okay. Are you good pretty much any time throughout the weekend?
I'll say yes.
Okay. And that's varying. I just didn't know if you had a specific day you may or may not be available.
Yeah, so I think Saturday morning I've got something,
Okay.
but other than that, I'll be open.
I'll try to avoid that then. No problem.
All right.
Got another question too, if you got a second.
Yeah.
So they put out a thing at Y12 saying that they were going to be doing a kind of a mini version of this. In other words, it won't be a class, it won't be a degree, a master's, but it's going to be something smaller. You know anything about that?
I think it's their certificate program.
Yeah.
And I think it runs the equivalent of a semester. I don't know how often they meet. But yeah,
So-
it is a speed dating version of this.
Yeah, are you gonna be a part of that?
I was a little bit a part of the earlier one. They focus more on systems level sorts of things, and so they spend a little time doing each part of this. I don't know that I see that Craig popped online. I don't know that they do project management. They don't do any design of experiments. I know they do a little bit of the systems dynamics modeling. They do a lot of systems thinking kind of stuff. It's got Dr. Soni's spin on it, which is a good thing.
Okay,
I like his approach. That's what I know about it. It's a good class. There's a number of people certificate program. There's a number of people that have gone through that. So they'd be good to ask.
okay, so that's already been done?
Yes. So I think they're
Okay.
completing one and they're launching it. This might be their second or third one. I can't remember.
Yeah, we're gonna be starting the second one, and I think it's gonna be so it's 6 months of basically classes, but you meet twice each month. That's how we did it last time. So it was 12 classes, and then it's a 3-month project.
Okay, I just had some inquiries about it from other folks.
So yeah, it's basically just a shortened version of this class, the classes we're taking.
Awesome, thank you. Thanks, Tom.
Yeah, y'all take care and get a hold of me if you want to chat about something. See y'all later.
All right, let's see. You guys still take a break, whoever's there. If someone can give me control of the screen, that'd be great. It says host disabled participant screen sharing. Still disabled.
You should have it now.
All right. Perfect. Okay. Good deal. All right, I'm going to set it up, and as you get back from whoever's there, if you need to take a break, go ahead and take a break, and we'll start when I see a bunch of people pop on. I'm tired already. Won't be long now. It'll be almost Thanksgiving. Anybody there yet? See Rob. I see Michael. Harris. Mia. Lucas. Tim. Alex, I see you coming out of the water. Coming out of the water. And so dry too. That's amazing. Harris, I see you. Tim, I thought I saw you pop up there. Was I imagining that? Yep, I see you. Joseph looks like he's still out. Let's see. We'll wait till it says 06 and then I'll start. This is a really dry one, guys. This is one about contracts and it's going to be, oh yeah, it's so exciting. I don't have a lot of graphics to show for this one. Yeah, money. Rob says money. Yeah. I had a minister one time and like all big churches now, there's a lot of big churches, they have sign language next to them. And so this guy would always use symbols that meant different things in sign languages with his hand. So he'd be talking different ways. And the sign, it was a joke because the sign guy would tell us what it actually meant, his sign language meant. All right, so let's see, it's 6 after. Let's go ahead and get started. This is going to be so much fun for you guys. We're going to talk about all kinds of things related to procurement and contracts. So all of this is still in play. We're over, when it comes to contracts, we're really on this side of a change. And we've gone through really the portfolio management system at this point. We decided we wanted to do it. And now we're going into making the change happen. So we're trying to set up all the procurement contracts. It could be related to strategy. It could be related to continuous improvement. It could be related to just anything else in general. As far as, I left the books downstairs, I usually bring them up here. But as far as the concept phase goes, we don't really have a section in the PMBOK related procurement in the concept phase, but there are concept phase issues. So what we're going to do is we're going to think about kind of it in general terms. So if we look at procurement, we're at 12. We only have one more left to talk about, and that is stakeholders. And stakeholders and procurement are smaller sections, but procurement can be very complicated. We're going to have basically three different knowledge areas related to our process groups. that we're going to talk about. And then there's 3 different parts of that, one for each of those. So we're going to look at plan procurement, conduct procurement, control procurement, and it's going to go through the planning and implementation phases of a life cycle. Remember, that's not necessarily part of the PMBOK. That's just, you can call these things different things, but the process groups are important. If you're going to take the PMBOK, you need to memorize this chart, and you've gone through it up until now. So scope, and it makes sense. Integration comes first, scope, schedule, and cost. That's a triangle. We're trying to produce quality. It takes people to do that. Once we have people, we have communication. And then once we have all of that, we can start talking about risk, procurement, and stakeholders. So it's easy to memorize. You just have to develop some kind of plan to do that. And then, the process groups are important too. And it goes in a little more detail. So we're in a concept phase. So if we were contracting to an organization, we were the seller, then this would be kind of our steps, right? And all of this is going to make more sense, hopefully, when we go through it, because we're going to take it from the buyer's point of view after we look at the seller's point of view. So from a seller, we might have had a proposal, request for a proposal. So that's driving us, or maybe it's market driven where we want to sell this. And then we're going to, in that request for proposal, if we're working for a government especially, and we're trying to do something for them, then it's going to have a statement of work. We're going to address that statement of work, and we're going to have, we're going to look at each of the points of the statement of work and look at their scoring details and try to focus on the highest scoring ones and give them all the details we need in order to do their statement of work. A lot of times what they're giving us is from a point of view, they need a service done, and they don't necessarily know what that means. They may have smart people in the organization but they're not necessarily experts in our field. So their statement of work doesn't always make sense, but we have to address their statement of work, and we have to expand on it from their point of view, not our point of view. So a lot of times, if you're working for a large company, then you have a technical writing side of that where we're addressing all of this. And then we draft it, and we have a final draft, and we have a final draft. And, there may be many steps to that. It may be a first draft, second draft, third draft, final draft, things like that. And that technical writing will be a part of that. Then we have financing and accounting is, how much is going to charge, how much we need, how much it's going to charge. We have all kinds of estimating. We use graphics and editing. Some people, I think Martin Marietta, Lockheed Martin, maybe, after Martin Marietta came up with a system. I can't remember the name of it, but their proposals was half a page was graphics and half the page was words explaining the graphics. And that's worked really well at that time. They've probably changed that over the years. At the request for proposal, a lot of times companies will have a red team, yellow team, and green team. The red team takes all this stuff we've been talking about and just tears it apart. And it's a red team because they're redlining everything, and that's just, it's not ready to go yet. After that, it turned over maybe even to a fresh set of eyes. It might be a yellow team, and they go through and they highlight everything and tear it apart again. And by the time it gets to the next team, maybe a whole different group of people, they'll look at it again. And then once the green team's satisfied with it, they send the proposal out. So there could be teams of people, red team, yellow team, and green team. I don't know. Anybody seen anything like that before? When you're writing a proposal, this is what's going to happen. That proposal is going to drive. Rob, I think you're about to say something. So
yeah, I've lived in this world for the last, 2020, so 20 years.
Yeah. So you can probably teach this class better than me because
No. You go right ahead, Craig.
So what I'm saying is add what you know, and I know several of Michael, you probably have too, and some of you guys probably have also. I know Mia, maybe you have too, but check everything I say. This is what we used to do at SAIC, for example, and this also comes from the book Harold Kirschner, and he is the, let me just get the book. I'll show you what it looks like. It's huge. So this is what the book used to look like when you taught this class. You know, it's like getting an MBA in itself almost. And so this was Harold Kirschner's book, and it's just lots of detail. This is version, 7th edition. There's probably a 12th edition, and then he's no longer with us. So hope maybe it stopped, or maybe like some of the voters, he keeps going. I don't know, but anyway, that's a bad joke. So reproductions, contracts are in place, at that point when they accept us, and then we give presentations. That's all kind of together. I told you the worst.
You probably want to reverse those last two bullets, Craig. Presentations usually, depending on the deal, there's an oral presentation that comes into play. And then once it's allocated, then they get into contract negotiations and signing contracts.
Yeah, that's a good point. There is pre-bid meetings, and there's introductions for the finalists and all kinds of things in the middle of here. So presentations and contracts, and you're right. The presentations are happening several times up here, and
yeah, that's a great point, because actually the CNS is the folks working for CNS are probably very aware that there's a contract getting ready to go through. I think the final request for proposal was just released by headquarters, and they've already gone through multiple presentations, site visits where potential bidders have come and gotten presentations from the government in terms of what they're looking for, what the government's looking for, and to get a kind of lay of the land. And then there'll eventually be a final proposal. It'll get whittled down to probably a couple primes, and then they'll have some presentations and sign a contract.
Yep. And then throughout this whole process, you may, or if you're the project manager, you may or may not be involved with any of this until after the contract's signed, or you may be doing the technical writing. But a lot of times larger companies will assign a project manager after it's a sure thing. They're not going to pay the project manager. A lot of times this is the executive team, and they have a marketing team, and everybody else is doing all this work. And
I've been actually, Craig, these have been on the bidder side, this is an actual project in of itself.
Yep, you're right.
Actually putting together the proposal and the whole capture process.
Yeah, you're right. And that's a very good point, because anytime you go through a change, you have project teams involved, and you could have several stages within a project that have different project managers. And at the end, you may have a different project manager that's handling the cutover to operations, when it's everything's said and done. And a lot of times there's different names in IT world. The systems engineer may often be the technical project manager, whereas the project manager may be the facilitator, on the top level that interact with everybody, but when it comes to doing the actual work. So you can have several project managers. This process itself, like Rob was saying, could be a whole different project. All right, so now we're in the concept phase now, right? Because right now we're selling our services. This is what I would consider the concept phase. We're trying to figure out what we're going to do. And so with SOW, there's all kinds of ways to screw up. And so there could be you think of it, you got two different organizations with two different ways of doing business. And we're trying to figure out what those people we never met before are meaning when they say something, right? And then we're in a technical world, and we can get very precise language in the technical world, but that's not necessarily the people who are writing the proposal. That's not necessarily people who are writing an RFP. Sometimes the technical world has silos in themselves, and the people doing the work are trying to interpret, it's being interpreted a bunch of different ways. So there's the things you need to look at is you need to look at mixing the task up. Maybe we're thinking maybe we're bypassing each other. They're talking this way and we're talking that way, and we both have our own ideas of what the tasks mean. Maybe the specifications aren't exact, and maybe our specifications and what we assume that means is different. Our calibrations could be different, all kinds of things. The approvals and the special instructions may have that. Now, as we go through this, in an ideal world, we're asking all these questions, and we're going to the people who are requesting proposal, and we're asking those questions. And then as they see something that needs to be clarified, they send those answers out to everybody. And so there's several steps along the way that we're going to talk about in a little more detail, I think. Imprecise language, we might see that. No pattern, structure, or chronological order. We can mix these tasks up into a order that's not chronological in nature, and therefore it looks like certain things have to be done before other things, that because we're at a top level, high level, we're at that 30% plus or minus where we make mistakes in that magnitude. And we haven't necessarily had the project manager or the team involved to understand the SOW at this point, when we're getting requests for proposal in. Wide variation size and task could be, things we're used to are small, and the things. I was talking to a company on Veterans Day. It was a Veterans Day dinner, and this guy was a program. Well, he was a how do I say that? It was a marketing. He was the marketing guy for a construction company that did bridges. Okay, so that's his background. And he talked about there's this one project they had to put down bridges in rural bridges, and they may go to just like, they're small, they may just go to like a one run trailer, in the woods somewhere. So they had to put it down. What happened was the original contract put in a industrial salvage yards material over these streams and these little rivers, and it was highly contaminated with mercury. And so they found this out. They found a high contamination of mercury, and now they had to replace all these bridges. So to go to the Tennessee Department of Transportation standards, it requires, you have to build to that standard. It's all that construction company did. And they had to do 300 of these. Well, each one of them costs $300,000, to do. By the time you rip everything out, and it's going to one house or one trailer over a stream, but, it has to be done. But can you imagine the variations in size and tasks from the largest bridges to the smallest bridges, from a one-lane bridge, basically in some cases, going to just a house, and then a 4-lane highway, and all kinds of things. So wide variation of how to describe details of work, and that if I were to, I don't know if you ever played this game, but someone asks you there's a picture on a sheet of paper, and then someone's going to ask you to draw that picture without you seeing the picture. So say, we got to draw a line through the center of the paper. Well, some people may draw the line vertically. Some people may draw a line horizontally, and people, it may be a curved line to start with, and they forgot to tell you the details, they didn't tell you all the details. So wide variation, how you can describe things, and failing to get the third party to review it. So, and I think of this example of this would be Rob would say something and I'd say, Rob, here's what I think I heard you say. And then Rob would say, no, Craig, that you're way off. I had no clue where you're thinking that way. Here's what I'm thinking of. And I'm thinking about, what we're going to eat for lunch. And Rob's thinking about something about, trying to move a car from one direction to the other. And I'm thinking that we're getting in the car to go eat lunch, just all kinds of ways to screw it up.
These are the areas, Craig, where you start adding things to your risk.
Oh yeah.
Risk log and setting aside money for risk reserve and
yeah,
all this misinterpretation stuff.
Yeah, and let's see, let's see if I have some of this stuff. Well, I think I had all this. Well, I have all this somewhere. And for some reason, let's see, that's probably Excel spreadsheet. So example of a project proposal document. So this is, it comes in all kinds of shapes and sizes and looks. And so this is one I gathered from someplace if I can ever get it in front of me. And so this would be a checklist for a proposal, right? And companies have all kinds of potential documents to go through and look at it. But, this is kind of what that might look like. We're going to write a proposal. And since we've done these a lot, here's the kind of things that we put together in our checklist. We're going to describe it, and we're going to put a team together to actually write the proposal. And, so there may be checklists where we always have this section and this section and this section. And this is part of your company's assets of how you're going to, go through your proposal, maybe. All right. So all of that is what I consider the concept phase. It's outside of what the PMBOK was talking about. We're looking at it from trying to contract with others, but we're also sometimes the contractor, right? And so all of that is going to go into our concept phase, trying to figure out what it is that we're supposed to do. And once we win that, then we're into our planning phase of how we're going to implement that. Does that make sense, Rob? Did I say that right? Okay. All right. Sometimes I know what I'm trying to say. I just don't know if it's coming out. So you guys correct me. Let's see, procurement. We're going to look at this first part. This is the planning process, the planning of procurement. It's in the planning phase of a life cycle. It's also in the planning process group. So what you need to know is knowledge area procurement, process group planning, and then plan project management is what we're trying to do. So if we look at that, we have the project charter. By this time, we have and so now we have filling for what we want this project to do, right? And so all of this project management plan, this is one section of the project management plan, right? So we got all the business documents that justified our project. We're trying to buy services now from other people. And then we have project management plan that we're starting. We're going to put the procurement management plan into that. We have other project documents. We have our environmental factors, and that's how we do business, the cultural things, those kind of stuff. And then we have the operational process assets. And I gave you an example of maybe our checklist of when we do a proposal, you might go through that checklist. I didn't spend a lot of time on it because every checklist looks different, and there's probably, you could Google it and find a whole bunch of things. And I'll also put that on the app too. I'm going to start, I keep saying I'm going to start doing that, but I'm going to start doing that soon. And then our tools are expert judgment, data gathering, data analysis, source selection analysis, and meetings. And then out of this, we'll get the procurement management plan. If we look at McCahey's book, the one you have, then this is some of the areas under plan procurement management that she put down. Let's see. All right, contracts and procurement. If we look at, this is Harold Kirshner's, that big book I showed you. Here's what he says. Procurement is the acquisition of goods or services. Makes sense, right? That's important, because that kind of thing's on the test. Contracting is a process that involves two or more parties with different objectives who interact to give market in a given market segment. So those are just some definitions. Here's an example of a procurement checklist. So like the proposal checklist, there's also other tools out there that can be used, like the procurement checklist. Let's see if I have a picture of that. Yeah, don't know. All right, let's see. Anyway, so I don't have one. I don't have that ready to pull up for some reason. Maybe I do. Let's see. Well, anyway, I got a bunch of these. That's one I didn't pull up. But the whole point of that is that kind of like, this is just an example from some PMO that you're trying to go through and you're trying to document the things we're showing you and check off whether you do it or not. Just to keep yourself out of trouble. Kind of like conduct of operations, right? If you're familiar with that, you have a checklist that you go through and you know, what are you supposed to do at what time? I remember I put conduct of operations together for the baler at Y12, when the bail the trash, you know, that kind of thing. And so first thing you do is you walk in the door and then you go around and you make sure all the, you know, switches are put on in a certain order, and then you check certain things, you do certain things, and you start the process. Well, that's the same kind of thing. You have a checklist, kind of like flying a plane. You have a checklist of what you're going to go through to get the procurement set up. So the procurement management includes the processes necessary to purchase and acquire products, services, or anything needed from outside, and the process of documenting the decisions and specifying the approach and those kind of things. And it identifies those project needs which can best be or must be met in order to do this project. So that's the kind of thing in your management plan. So there's basic strategies, there's a corporate strategy, and there's a project strategy. So a corporate strategy in IT world might mean that we have a certain type of system, you know, we have certain infrastructure set up. So whatever we get has to fit into that. It doesn't, you know, can't fight that. And then the project strategy is how this new piece of equipment or this new software is going to fit into that corporate strategy. One's, you know, larger and one's smaller. But there's different constraints, different availability of resources. You can imagine at a corporate level, it's a little bit different than at a specific project level, because you being a project manager aren't necessarily CEO of the company, right? And specific customer requirements that are different for each of these. So how do you decide whether to outsource or not? So that's one of our questions. We can either buy or we can make, and there's a whole bunch of variations of that. So one thing we need to do is a cost analysis, cost benefit analysis. And then we also need to do a core competencies, organizational capability, and availability of resources. There may be things that would be so much cheaper if we could do it inside if we just had the right people. But, you know, a couple $100,000 later, then you can hire the right people. Well, that changes everything. If you only need this project once and you don't have the capability and you can't build the capability, then those are the kind of things you take in consideration. With the procurement objectives, we can do all kinds of different things. We can procure all the goods and services from a single source. We can look at all the goods and services from multiple sources. In other words, some from some places and some from other. Only a small portion of the goods and services, and we're going to do the rest of it. We may do it all. So there's a whole bunch of objectives in our procurement, and you can procure small parts of it. You can procure the whole project. You can procure, you know, nothing but computers, you know, things like that. So the macro and the micro is what we just talked about. You know, that's the corporate larger picture environment, and then the macro environment would be maybe we're within one of the divisions and we're in a smaller group. So those are some things to think about. All right. So if we were to put this together in a procurement contracting system, Kirshner lays it out this way. He says there's a requirement cycle, there's a requisition cycle, there's a solicitation cycle, there's the award cycle, and then there's the contract administration cycle. So we'll go through each of these. But so far, any questions or any thoughts or anything that should be added? We went through the proposal and we said, well, that's for us, right? Going outward. We're starting now to look at procurement from us being the buyer. So anything anybody want to add so far that I might have missed? We're just now getting into it, but any thoughts? How many, let's see the thumbs up. How many people, I know Rob, your thumbs up already. How many people have been involved in a procurement of some way related to this? So Jacob, Michael, Mia. And so Tim, how about you? Lucas?
I have not.
Okay, so this is good information for you. This isn't necessarily 100% correct all the time. This is just a view from what could be done in a mature system. And probably these steps are the minimal that needs to be done. I can't think anything that's missing from here. And this originally came from Kirshner. All right, Joseph, what's your background a little bit? Kind of.
Sorry, I was trying to get myself unmuted. I got two screens going on. Mine's more out of production. So these type of procurements, I deal with the backside of it, right? So
okay.
I watch from the user side as these things get developed and get used. So it's a little bit different from where I sit from viewing the project manager versus being the end user of the project. Does that make sense?
Yep.
It helps to understand what that process is and why I see certain things happening along the line.
Yeah. So if you think of something you see that's a negative or a positive, ask that question so we can address it as we go. Like I said,
well, Craig, this probably comes to speaking to what Joseph's involved with. It sounds like as part of the contract administration cycle, sometimes the government will change a policy or a regulation or something that could impact a contractual requirement. And many times at Y12 or Pantex, the operations maintenance folks have to submit information up to the customer to say, hey, this is what it's going to cost because you're changing the contract. You're changing a key aspect of, for instance, the mercury thing. Not only were you putting up bridges to it, now we got to do all this remediation stuff. That's different from what we thought we were getting into. It's going to cost you an extra $50 million.
That's right. And people probably got promoted for making those bad, that bad mercury decision. They probably said, oh, we saved Tennessee, millions of dollars because we found this great pile of perfectly already designed and built metal bridges we can use. And, but then someone in the operations side of that will only know, they'll be the subject matter experts of what's required to do that operation. And when we're talking about requirement cycle, that's the people you talk to. So if you're in the procurement, you got to bring in those subject matter experts that are actually doing the work. And that's your voice of the customer, for example.
So what we see a lot of times is, and we've got multiple little projects going on right now, right? And these projects are fairly major for the facility, probably pretty minor for the plant as a whole. But you'll end up changing things that historically have been one way, one reason because it just doesn't exist anymore. Technology's advanced or whatever, right? So when they bring those in, they try to retrofit the existing items already.
Yep.
And it does increase the cost, change the time, so on and so forth. So we see that, but don't necessarily put the reasoning behind it.
Yep. And so what we said here up here, organizational capability, let's see, somewhere we're talking about, we just talked about it, but that's a good point. It's got to fit into that system you have. And if it doesn't fit in the system, maybe the whole system has to be changed, in some way. And so, but the people at the end of the whip, the people who say, ouch, when this is over, are the ones that, they're the ones who have to live with it. So the requirement cycle is the definition of the boundaries of the project. What we're trying to do is we're trying to figure out what the scope of the project is, what are the boundaries. And it says the first step is to find the need for the project. So all that up front in that portfolio management system that we talked about, making sure we need it, it's the high priority, we got to go forward with it. So we got to define that, so that we can understand the people we're trying to get to come in and do that for us. We already found a need for it. It's already gone through our portfolio system. We're already starting the project in a concept phase, but now we're planning out the procurement. So develop SOW, the statement of work, specifications, WBS. So what we're trying to do in the very first thing we talked about is us being the seller. We're going to look at the SOW from the buyer. Us being the buyer, it's to our it's critical that we get the statement of work down, because we're going to ask somebody to provide this for us, and we're going to spend a lot of money for it. So we got to know the specifications. We got to go to Joseph and say, Joseph, tell us what we got to replace this piece of equipment, no longer exists. What's the function of it? What does it do? And what do you need in order to keep this operation running? And then WBS, what's WBS again? It's a work breakdown structure, and that's spelling out our deliverables. So it's going to be important for the people who are going to provide us the proposal to know what their deliverables need to be, right? So we need to know that first. And then we're going to do a make or buy analysis, because after we know all of this, we got to decide, well, is this something we can do? Is this something Joseph can fabricate in his area? Or is this something that our other metallurgical fabricators can do? Or is this something that we just can't do? It's just too expensive and has, it takes retooling and all kinds of things before we can get these parts. And then we're going to do the buy analysis, which is going to talk about cost and all things. Then we're going to lay out the milestones and timing and schedule. So we went through all of that before, right? So we may bring the project manager in to do some of this work, or it may be done before we ever have our project manager. When I was working with Ardent Healthcare, they had 30 hospitals. Every time some software package or some kind of thing came in, it was manufactured somewhere else, right? Programmers did it. The software is owned by Microsoft. The software is owned by Oracle. Software is owned by, some large company. And so me being a project manager, we were going to hire them to do it, but I have no clue what their milestones and timing takes to build their piece of equipment, right? Or to implement, because they've done 100 of these and we have 30 hospitals. We're going to apply it to 30 hospitals, but we've never done one of these before, right? So I have to communicate. This is along the way, right? I may need to see their milestones. I may need to see their timing, and I may need to put that into our SOW that they need to provide that with us along with their proposal. And I may have a general idea. I may say, well, we need to have this done in the next year, so it's got to fit in that milestone and those kind of things. And then they may say, well, this is a 3-year job, so we have to, it's a little bit of trial and error to get the requirements in. Cost estimating, including life cycle costing. I like to call it cradle to cradle costing, because you got cradle to, it's growing up into your system and then it's going to die out someday and you got to replace it. Well, you also have to, pollution prevention requires us to think about, well, how are we going to send it to the next step? How are we going to get rid of it? What are we going to do to make sure that it's used somewhere else or it's recycled or something? But also it goes back to another reuse in some future place. And sometimes we're involved in that, sometimes not. But life cycle costing, the whole life cycle of it. So disposal at the end and everything. So then we got to obtain, once we know a little bit of this, and we've already decided we need to do this, we're going to also kind of go through another portfolio management system in that we got to get approval and it could be denied. So it's not a sure thing until we figure out for sure. So the requirements, and remember we went through the requirements, went through functional requirements, attributes and constraints. So we're thinking functional requirements, attributes and constraints, because that's where most projects fail. Anybody want to add anything to that? Michael, Mia?
No, nothing to add.
Okay. Does it sound like I'm on the right path, Rob? Sound good? All right. All right. So requisition cycle. So now we know what we want to do. We've documented everything. Now we want to go and actually get that, right? So we're going to go through some cycle to make this happen. So we're going to design the specifications. We're going to look at performance specifications. We're going to look at functional specifications. This is all part of the requirements. So now we're focusing on expanding that statement of work, right? So we're going to describe items in sufficient detail to allow the sellers to determine if they can do this, if it's profitable for them to do this, if they have the right products, if they have the right services, if they can get us the results we want. And because that's on their side, this is important too, right? Because they could go bankrupt by trying to bite off something they can't handle or chew, I guess. And the procurement SOW is developed from the project scope and baseline. So we look at the scope statements, and this is where the WBS becomes more important. And a WBS dictionary is connected to those deliverables and those things, and it's explaining, each one of those things mean. Remember, WBS also includes a unique identifier, which would be the WBS number. So, we're going to tie all these statements together to as much of those deliverables as we can. So now we're going to look at issues related to, do we make this or buy this? We're going to go into detail. Are we going to lease this or buy this? Maybe a little bit difference here, right? Buy or rent, lease or rent, and they all have slightly different meanings. And let's see, I'll look at this for a second. So this is an example of price quoting templates. So as part of that, we will need to, let me bring this over. This is another example of from somebody else that's using it. So, and this is part of your own organizational documents, right? So you may have a whole different system, but what we're trying to do is we're trying to find some way using our systematic and repeatable processes to look at how much it would cost for us to either create this or to buy this. And here's an example of equipment list, for some operation. And so we're going to go in and we're going to say, okay, and yours is going to look totally different. I'm just showing you that you have documents that will probably, if large companies will have documents that you got to use in order to put everything in, compare everything in a way that's compatible, or you can contrast one with another without trying to contrast apples and oranges, for example. All right, so we use tools like that. And so when we make our buy, we're going to have some constraints for us. So it these are some of the pros and cons. So make may cost less, may cost more. You don't know, but it may be easily integrated to operations because your people are putting it together and your people know. A lot of times a make is common in IT because you might say, should we build this in-house or should we buy something off the shelf? If we build it in-house, if we design it and program it in-house, we have pros and cons to that, but there's people out there, that's their whole life, their whole core competencies around building things. So it may cost us more to build it inside.
Because my IT brethren would shoot me if I didn't bring this up with everybody on this call. If you're ever involved in helping make a make or buy decision and you say, yeah, you want to make it, make sure you include the cost of operating and maintaining that solution, not just the implementation.
That's right. And because like Rob was saying, you can program it to the best of your ability. It works great and everything else. And then something triggers it to break down, some bug somewhere you didn't have background. You didn't have the background to see or something. But if you know, for example, if I were to program Microsoft project software, well, it's been around forever. Why do I need to program it? I can buy it for $50 a piece, and it's going to cost me $50 an hour of somebody's time at the very least to actually program it. And and on and on and on. And then it breaks down, has to be maintained and everything else.
That's a great example, Craig, because if you buy a copy of Microsoft Office, you purchase it for a couple $100, but you purchase it for an enterprise like CNS, you're going to have probably monthly releases of bug fixes that are going to have to be tested, validated, and then rolled out to every user every single month for the life of that product. That comes at a cost.
Yeah, and then just one time screwing that up, and you paid that for that software, and each time you want to update it, you paid for it again, and each time so you're paying that for the lifetime, whereas it might be subscription that's just cheaper because it's 300 people using it. So existing capability, if idle, so that may be another reason. You may say, well, we're going to have to lay off people unless we find work for them to do. This may be a good reason. You may say, well, we're going to keep people busy. We're going to take on that. And we know that we want to do this because we need these people and it's off season and we can't just lay them all off and bring them all in. So you may actually have capability idle that you need to use. And that might be part of your consideration. Direct control of it, you have more. For example, we had software, another software example, we had software that we needed control of all the data in the software. And once we asked a couple more questions, we found that we couldn't even use the software we're going to buy because it goes through North Korea, or it's a real extreme, but it goes through some other country that's on our blacklist. And today, almost all the countries are on the blacklist. In healthcare, you have to have it almost internal or like from England, someplace that's on the very green list. So may want to maintain secrecy, I think is what I'm trying to say. Avoid unreliable supplier. Maybe we've had bad experiences and we're just going to do this. Maybe also that supplier could be your competitor in some way. So as part of our core competencies required to stay in business, stabilize workforce. That's kind of like idle, again, a stabilized workforce and we bring it inside. And then to buy, it may cost less. This may cost less too, right? Use skills of supplier that we don't have. We don't have these core competencies. We don't want these core competencies. I remember a trucking company I was talking to at one time was merging with are breaking off their financial accounting department to be a separate company. And because the trucking company's core competencies, what they had to be best in the world at wasn't accounting, it wasn't finance. By breaking that out, it became another income stream because they sold this to other trucking companies, you know, their services and other companies. And then the trucking company that was split off, they could focus on their core competencies of moving things from one place to the other. And then the added benefit that nobody thought about, which is obvious, was that the accounting company now became the supplier to the trucking company. So the accounting company, you know, when it was part of the trucking company, there is a conflict of personalities there, right? So they were always fighting with each other. Once it became a standalone company, that trucking company go any company in the world that wanted to, it didn't have to use this company. They became client and customer, or customer and supplier. And so that changed the whole quality of how well they served the trucking company and everything else. So I'm saying that to say the skills of the supplier, you don't want to be best in the world at everything. You want to be best in the world at those things that require your core competencies in order to do the function you're trying to achieve. So if you have a good relationship, you're going to have a good relationship with a company that their core competencies want them to be the best in the world at that particular part. So if outside of what your core competency should be, you might look at splitting that off and getting a supplier instead of producing in-house. Did that make sense, Mia? Because I think I said it right, but I'm not sure it came across right. All right. Small volume requirements.
Just real quick, that could also go the other way sometimes. Something that used to be fairly complex that you decided as a business, yeah, we don't want to mess with this. We're going to outsource this or have somebody else take care of it, buy it as a service. Over the course of the time, as you're reevaluating that system, you find out that the software is now so advanced, or your ERP system is so advanced. Hey, we can bring that in-house, make this little tweak to our software, and save ourselves a lot of money. That CNS recently did that as part of their payroll process. They brought something that had previously been outsourced because it was complicated, complex software. It evolved to a point to where, hey, we can easily do this in-house now and save ourselves a bunch of money. And they did. Save millions of dollars for the company.
Yep, that is a good point. Thanks. Yeah. All right. So let's see. And so that is the whole point, Rob, right? So you're going to do a make or buy analysis to see what makes the most sense. And those kind of things that Rob just said are exactly right. Small volume requirements, it's not worth scaling up. Limited capacity or capability, that's kind of like stable workforce and idle. Augment existing labor. So let's see, we got 4 minutes, right? So I think of, if you think about draining a lake, say a real rocky lake, you know, this has got crags and got these rocks and boulders. If you drain that lake, then you have, and you fill it up with water a little bit, you got to fill it up to the point where there's smooth sailing, right? So that point that it comes, well, it's better if I can draw it out. Let's see, is there a way to draw this out? But anyway, so you fill it up to a certain point, and that's your stable workforce. Then you add temporary employees to kind of fill up those gaps, right? And then anything above that, maybe you have contracts to fill up. So you're trying to fill it way up. But if you think of supplying your labor, you don't want to have the full pond full of labor. You want to have, and I'm really screwing this metaphor up, but you want your labor to be at a certain level, so you don't have reductions in force and hiring capability, but we only need it certain times. let's see, augment existing labor, that's that part. Maintain multiple sources. Sometimes this was really done, had a lot of problems in a lot of different ways, where someone has one supplier that supplies everything, and that's it. That's their main supplier. Well, if that's the case, then what you may find is that supplier may go out of business, or that supplier may decide that we're your only supplier, therefore we can charge anything we want. There's all kinds of ways to look at it. So you may have a buy decision just to have more suppliers so that you're more stable. So indirect control is on the buy side. So let's look at this for a second. Let's pretend like this first X, that's a 1. X1 equals $4,000, right? And then we're going to buy the computer. The cost is $4,000. We're not looking at time value money here. And then plus a annual warranty cost of it's X2 is $300 a year. But we can lease this for X3, which is $1,500 a year, and plus down payment of a X4. Now this is just, the variable 4 of $400. So our decision depends on the number of years. Does that make sense? So how long we can hold this and buy it, how long it takes to lease it, and without thinking about time value money, because that complicates things a little bit, our decision is really why. So how many years should the lease equal buying? So if it's, in this case, let's pretend like, we'll do that calculation. Let's see, do that calculation during lunch and come back and tell me the answer. And let's take a lunch for 30 minutes. And then when you get back, just do that calculation and tell me what the answer is. How many years make sense to buy, or does it make sense to lease? What is that point where it changes from buy to lease? And we're not going to talk about it until we get back for lunch. So everybody go eat lunch, and we'll be back in 30 minutes. All right, anybody there? I see Michael. I see. Is that Rob or Mia? I see Mia. Yep. Had a big square and your thumb was right up against Rob's name. All right, so Mia, what'd you get?
3 years.
3 years. I think that's right. So 3 years. So y equals 3 years without looking at time value, money, and all that stuff. But I think, since it's all the same, it maybe this is good enough. So if it's older than 3 years, what do you do, Tim? If it'll last longer than 3 years. What about Alex? What would you do? What about Joseph? Yep, you just buy it. And that's, it's that simple. Here's a little formula that goes with that. You should have this. I sent it to Omkar late, and so he'll put it up if he hasn't already.
I have put it, Professor. I've uploaded it.
Yeah, I sent it to him just right before this class, so that was my fault. All right, so terms. Bid, tender, and quotation used when the seller selects decision is based primarily on the price. Then you'll hear things like this. If it's a proposal, then that term's related more to it's the capability or the quality or the technical approach. Then that's when you'll see more of that. Let's see, the next one is 2. Where did number 2 go in our... Anyway, so I'm missing something. We'll end up with it sooner or later, but I think I'm missing what comes before 2. Huh. All right, so I'm missing part of this, but we'll get back to it. So now we're in the implementation phase. Up until now, we've been in the planning phase. And so this requisition cycle goes into the implementation phase. Once requirements have been identified from form is sent, sources are analyzed. So anyway, that sentence doesn't make sense. But so what this cycle would include also is evaluating and confirming the specifications are current, confirming that the sources that we looked at on our we have a couple of sources of information, but sources of who can provide this service or this product. We're going to review their past performance, and we're going to produce the solicitation packages. So we have already, by this point, we're still trying to find who is going to do this work, but it looks like I'm missing a whole section. Let's see if I can backtrack for a second. All right, let's see. Yeah, requisition. All right, hold on just 1 second. Looks like I might have skipped something. Well, this one goes down here. It's not a big deal, it just threw me off. Okay. All right, so terms, we got that. Resave this. If I shuffle my deck, it throws me off. All right, so requisition cycle still. And then there's some ways to look at these are control and planning documents. So there's a controlling, this is examples of what a control and planning compliance review might look like pre-contract and during the contract. And then this is the also to compare, your different sources. And I can show you pictures of that in just a second. If I can find them, hopefully I got them. Let's see. Let's do the pre-contract one first. Well, pre-contract one isn't up here, but I can show you the contract one. So this is what those documents might look like as an example. So this is control and planning compliance review. And there's, different tools that this one has. And so it's looking at key, you're using a checklist to figure out whether a specific group has what you need and can provide what they say they can provide. And so this is just an example. You can put all kinds of different criteria here based on your industry. And then this one has, just a way to evaluate the different groups. What you're going to do as you start collecting, you're going to start looking at, the tools with your SOW that you provided as the person who's buying, as the company that's buying, as the organization that's buying. You're creating a weighting system on those SOW type of deliverables you want. So you might have it based on criteria like quality of work has a certain number of points, and speed and their history of performing that, how many projects they've done, and things like that. So you base different weighted criteria on what you think is most important. And that's oftentimes in the SOW and should be, so that the people who are writing a proposal can spend that much time focusing on that particular criteria of the request for a proposal. So that would be like, we're real interested that we come in on the time schedule, certain in 3 months. We want this done in 3 months. So we may wait that time in 3 months to be 20% of our points, or 30% of our points. And then we might be also interested in that the quality meets certain requirements, and we may rate all those quality criteria to add up to 30% of the points. So that right there, if they're on time, they give us the quality we want, then that's half their points, And so they're going to probably understand that spend those two, and there may be 10 other things, but the other 10 equals the other 50% of the points. So does that make sense? Rob, can you explain that better than I just did? Or anybody? Michael? Or did I confuse it enough where it's confusing?
No, I wouldn't say explain it any better. There's certainly unique instances or unique applications for all of this stuff where we are, but it's certainly clear to me.
Okay. And in this case, it might be related to schedule. You could focus one of these on just schedule. You could focus one of them on, on how you're going to meet the regulation requirements and that kind of stuff. And then all of these different sections could have each of those different criteria. Rob, do you have anything else to add?
The only thing, this helps, to think of this during the planning process before for federal acquisition requirements is usually always a good practice, because having everybody evaluate based on the same criteria, and then as well as having it documented, so you've got an audit trail when and if a contract gets contested.
Yeah, and that happens sometimes too. Mia, do you have anything that you're familiar with in your PMO that you want to add when it comes to procurement and measuring the criteria for different, you may have the top 3 providers, and how would can you give advice or any other ideas related to what PMO might do? Or is it not even got to the PMO yet, which is most often the case? This is even before it gets to the PMO.
No, I don't have anything to add at this time.
Okay. And so so I asked me a question, then I second thought it, right? And so a lot of times before the PMO even sees any of this, the selection has already been made. And sometimes the way that works is the division manager, let's pretend like you have a division manager who needs additional hardware in order to do the operations, right? So they've gone out and they already did research and say, man, if I had this hardware, our productivity will go up by 30%. And so this is the state-of-the-art stuff going on in the world. And there's 3 providers that provide it. We're going to automatically put these 3 providers on our short list, but we're also going to see if there's anybody else out that does it. And then so we might need a systematic and repeatable way to compare those 3 and anybody else we find, so that we're looking at the same thing. We're comparing apples to apples and oranges to oranges. And that would be where, you know, you might have a whole bunch of different systems. And it comes into a list that looks something like this. I added this column to it. Got something in my throat. So I added this criteria, the indicators of the criteria, and the weighted value. In this case, it's 1 to 5, so it's not very complicated. We could use that 1-to-1 comparison once we get all the criteria, and we can rate it by, you know, that. Indicators would be the difference. So this is the ability to do the work. So the indicators are, well, we can get an indication if they have the ability to do work by our past experience with that seller. It may be we have no past experience, so it may be not applicable. Number of resources they have. Maybe they have 10 people they can bring on site, right? And another group may only have 5 people they can bring on site. You know, that may be an example. Well, this list could be 100 long. You know, you could have 10 criteria and a whole bunch of indicators for each criteria. Like quality of work might be related to their recall rates, you know, or something else, you know, that'd be an indicator of their quality of work. And so what we were going to do is we're going to try to get that same criteria with you know, I added the indicators, and this is misspelled, but that's what it's supposed to be. And then we're going to rate it. And that's an example of that. All right. So that all is in the planning phase. Now we're going to go into implementation phase. So here we are. We're going to probably finish a little early. This is a short chapter. It's just a complicated chapter. And I say that, but then we're going to get into more complicated stuff now. So it's a short chapter, but it's kind of complicated in that, you know, when you start adding legal things to it, then everything gets more complicated. And it may take the longest amount of time to go through this and all the other things. So anyway, we have inputs over here into the conduct. Remember, we're in the implementation. That should be implementation, not planning. And then inputs would be project management plan, all these same documents, seller proposals. Now we got the proposals and are coming in at this point. We're going to use our expert judgment. We're going to use bidder conferences, and we're going to use data analysis and interpersonal skills. And our outputs will be sellers. We're going to select the sellers during this process. We're going to look at the agreements. We're going to change requests and project. We're going to update project documents, and we're going to do that twice because I missed something. And we're going to look at the improving our organizational assets. So all those little systems we have, we're also going to use that as lessons learned and improve on that too. If we're looking at the implementation phase from Rita McCahey, then these are the 4 things that she thinks is important related to that. So here's kind of what's an example of the procurement process. It's we have procurement management plan. We have procurement documents, all those things we showed. We have source selection criteria. That's that list that we may come up with. We may use those pages, those forms I showed you that will give us a little bit more structure to that. The tools, we're going to advertise. We're going to use analytical techniques. We're going to have bidder conferences. And then the seller proposals are going to be inputs coming in. So we're going to have independent estimates. They're going to be their estimates, what the work costs, the seller's estimates, and our estimates, the buyer's estimates. And then we're going to have a proposal evaluation. We're going to use all these things things we're collecting over here. We're going to start evaluating. We end up with a selecting of a seller. Somebody's going to provide us either a service or a product. And then we're going to go through negotiations with that one or two groups. We could negotiate with two, and we could, it could go all the way to the end where we get the best deal is one that wins. And then we have an agreement of what we're going to do, and that's going to be the contract. So that's overall what it looks like. So now we went from requirements, went to understand what we need, requisition cycle, we're going out and trying to find it. Now we're actually are putting that information together. And now it's the solicitation cycle where we're going to start communicating. So solicitation package would be the bid document. It could be listing of qualified vendors. We're expected to bid on that. So we're going to send this package out with a request for proposal in it and all the information they need. And then we're going to have a list of qualified vendors. You know, we're going to have qualify them in some way. Maybe they have to be pre-qualified. Maybe that's a list that we sent out before. And we're going to evaluate, you know, what our criteria is for evaluation. Once they start coming in, we'll have, and before that, we'll have bidder conferences. We'll invite people in, and the government will invite people in a way that we can't just invite necessarily, you know, there's certain rules to that. Maybe we have to invite, maybe we have to have it advertised for 3 months, you know, and before we can have people come in. And then, so we're going to explain how change requests will be managed, and we will supply payment plans, you know, those kind of things, what we expect. And so solicitation cycle, the bidding process. So 3 common methods of acquisition. We advertise it, negotiation, and small purchases. So there's could be that we already have someone who's providing work now, and we use a sole source. So really we're going into negotiating with a sole source, and we justify that, but we may still have rules associated with that where we have to look outside too. And then very small purchases could be something like we have a credit card with $3,000 on it. So if it's under $3,000, we don't have to go through this whole thing, you know, that kind of thing. There's procurement documents and negotiation, and these are the types of documents, are the types of things we can look at. There's a request for information, just looking. We haven't decided whether we're going to do it yet. Request for quotation. It's more cost centric. For example, we need computers. And so now we just want quotations from people, how much they can provide these computers for. Request for proposal. This might be, we have a service that's kind of complicated, and quality is the most important thing. So now we need a proposal. It's more than just a product that we can buy off the shelf. Invitation to bid. For a bid, we can send that out. Sole source or non-competitive process. We have certain groups that are in non-competitive. We may have a service disabled vet owned company set aside. So, and there may only be one of them, you know, that can do that work. So that's a set aside that is non-competitive in nature, or it could be another 8A type service where it's a minority owned small business where we have 20% we have to spend on that way, and we haven't met our quotas yet. And so there could be other non-sole source, like this is the only people in the world can do it. They own the patent and no one else needs it. We need that because that's the process we have. Or it could be an old piece of equipment and there's only one group in the world that maintains those parts, you know, that kind of thing. Desire a form of response from seller. So we got to tell them what kind of response we want. And a non-disclosure confidentiality agreements may be part of those documents. Can you think of anything else, anybody?
Conflict of interest.
Conflict of interest, yeah. Conflict of interest. Very good.
the bidders may have participated in some earlier procurement, and so maybe they prepared the design, and so then they would be nullified from being able to compete on it unless it's a turnkey procurement.
Yeah, could be. Yeah, it could be some restrictions on that. I know that before we even got to any of these, we had to have security review documents with people so that if they don't have that on file, then they can't even bid on, or they have to put that on file, and that may be a lengthy process in some cases. Negotiation major factors. Compromisability. Can we compromise with them? Is this something where if we give a little and take a little, and is there even ability to do that? Is it adaptable to some other method, or maybe it's an old piece of equipment, but we can adapt it in some way to update it, and then good faith. That's what we're working in. We're trying to work in a form that we expect things that we write and will come into play, and those kind of things. All right, so negotiation activities, develop objectives. So it might be a minimum and maximum, it has to fit in a certain specifications, and we have control charts related to that, or we have a minimum amount that we need, and then with up to a maximum amount. So we just, our objectives. Evaluate your opponent. So it may be that we have to think about not only the person that the group we're getting in, but also any competitors or any other groups that are associated with it. Define your strategy and tactics. Okay, that's beforehand. Gather all the facts. That's going to be everywhere. That's data gathering, right? And data analysis. Perform complete cost analysis. So if we haven't done it to this point, then we need to go back and look at the price and cost analysis of the different groups. That will come in as it's coming in. It will come in proposals, and we'll be able to compare. But we also will learn things from the proposals, because we're assuming that the people we're going to hire have core competencies we don't have in some cases. And then there's other hygiene factors, and those are dissatisfiers more than anything. So if it looks like we want certain things that aren't necessarily, it's just part of the, we'd be more satisfied if they could do this too. And now we went through requirement, requisition, solicitation. Now we're going through a award cycle. Contractor selection and contractor awards. So objective is to negotiate a contract type and price that will result in reasonable contractor risk and provide the contractor. You know what? I think I have two computers I work on. I think I did my spell checks and a correction on the other computer, and it didn't get stored up to OneDrive because I keep finding the and different, little mistakes that I thought I corrected, little misspellings and things. Basic contractor elements. So mutual agreement, offer, and acceptance. These are the elements. So we're going to make an offer. Somebody's going to make an offer. Somebody's going to accept it. We're going to have consideration. What's the down payment? Contract capability. Contract is binding only if the contractor has the capability to perform. You can't force somebody to present something that doesn't exist or can't exist. Legal purpose, the legal purpose of what we're trying to do. Form prepared by law. Provide by law. Reflect the contractor's legal obligation or lack of obligation. So this is kind of the scope and the statement of work, and delivery end result. So we're trying to understand, what it is that we're trying to do. 2 common contractor forms. So the completion contract, we got 3 here, required to deliver the definitive end product or service, could be a service, right? Upon delivery and formal acceptance of the customer and contract is completed and final payment can be made. All right, term contract is delivery a specific level of effort, but not necessarily, end product. This is you're gonna come in and help us sell Christmas ornaments during the Christmas season, and we're gonna just hire you for a certain amount of time. Hire your team. Maybe it's a bigger project. When effort is performed, the contractors no further obligation. Payment is made regardless of what was accomplished. Whether we sold a lot or didn't sell a lot. Letter of intent, primary written instrument, not to exceed face value of the contract. So we're going to provide you a term contract for your level of effort, but we're not going to spend more than $20,000, something like that. All right, terminology. We're going to get into the contract types, and that's the thing that you probably, if you're looking at the PMP, that's the thing that's going to be something you really need to know. All this other stuff is kind of boilerplate, gets you to where we're trying to go, but it's still important. But when it comes to the actual contract types, that's the part that will be hardest on the test, I think. So terminology: target cost or estimated cost, target or expected profit, so target profit, profit ceiling or profit floor. We're going to pay you at least this much up profit, above what the expenses are, and we're not going to pay you more than that. Price ceiling and ceiling price. Let's see, price ceiling or selling price, same thing. And that would be, we're going to pay you up to this amount, and it's not talking about profit. We're just talking about, we're going to pay you for this computer. We're going to pay you up to $1,000, and we need 100 of them, that kind of thing. Maximum minimum fees. So above all of this, profit, price, and everything else, then we're going to guarantee you a certain amount of fee on top of that. So you're going to get this stuff for cost, and we're going to pay you a certain amount of fee in order to get that kind of stuff. Sharing arrangements or formulas. We're going to share the profit and loss by 60-40. We're going to take 60, you're going to take 40. If we make more profit, you get 40% of that. If we go under and we spend more than we want to, you're going to have 40% of that, that type of thing. Point of total assumption. All right. Anyway, so contractor base, we're going to look at overall degree of cost and schedule risk, and it's going to be based on this type of complexity. So our contract's going to be based on the degree of risk, schedule and cost risk. Our contract is going to be based on the type of complexity. Maybe it's really technical. We can't find anybody else to do it. It's high risk. So our contract's going to be based on that risk. The extent of price competition, maybe our contract's going to be based on, because there's two different groups doing this, you're in competition, we're going to take that in consideration too. Cost price analysis, urgency of the requirements, and performance period, how long it's going to take. Contractors' responsibility and risk. The accounting system is capable of earned value reporting. So when you remember, we went through all the earned value when we were talking about scheduling and costs and those kind of things. That's hard. Not every company has that. And so when it's available, and then that may be part of what we look at the contract type based on how well they can report to us how well everything's going. Maybe we have a bunch of contracts going on, and so this will be put on the back burner at times or brought forward on times. Maybe this is higher priority or lower priority. The extent of subcontracting, how much work will be done or outsourced. So if you had, if we're getting a contractor to come in and they have to outsource everything, they're the contractor, but they're getting carpenters and they're getting plumbers and they're getting other people come in too. So that could be how we base our contract. All right. Whew. So I went through a lot, and most of it is really dry so far. So how many people fell asleep so far? Are you guys? Joseph raised his hand. Michael's raising his thumb up. Alex, and so that's one way I can get everybody to participate. How many people are falling asleep out there? But this is the driest part of the project management process. It's one of the most complicated parts of the process, and it's the one that requires the most legal interaction, and it's the one you may have to do the least of as a project manager, but it's something you need to know to pass the PMP. Does that make sense? So fixed price or lump sum. So he has a fixed price with nothing, nothing at all. Has a fixed price with a redetermination, incentive fee, adjustments, economic adjustments, and all these things. We'll go through some of this. All right, so here it is, fixed price or lump sum. That's a type of contract. The seller carries the highest risk. The seller's actual profit is not known at the time of the contract is signed. So that's where the risk comes from. So fixed price, you're going to provide me X for $100. I don't care if it takes you, and you're going to do it in 3 months. I don't care if you have to hire one person or 100 people to do it. I'm going to give you $100. In 1 month, I expect this. So you can see the seller carries the higher risk. That makes sense, everybody, right? Thumbs up. All right, so now firm fixed price with nothing is the most common contract type. Price of goods or services is set at the beginning and is not subject to change unless the scope of the work changes. It's mostly used for delivering materials. So I'm going to give you $100. I'm going to give you $1,000 for 100 computers, $1,000 each, and you're going to give me 100 computers at $1,000 each. They're going to be this standard and everything else. So that's fixed price. We agreed on that. You say you can do it. You got your profit in that. You're going to deliver it. You're going to set it up. Everything we agreed to. And if for some reason computers become harder to find and it's going to cost you more, so it costs you $500 to buy one, right? And you're going to give it to me for $1,000. If it costs you $700 to buy it, you still take that risk, right? And so that's that. So fixed price incentive fee. This is some incentive may be offered if the contract meets certain quality requirements or is completed ahead of schedule or some other thing. So this is with redetermination. It's called, so you're going to give me a incentive fee for giving me those 1,000 computers or those 100 computers at $1,000. If you can get them to me at $800, I'm still let you keep the other, or, if that's what it costs you, it's your fixed price, you're all set. If you give it to me, I want it in a month. If you set it up in 2 weeks, I'll give you an extra, $5,000. That's your incentive fee for getting it there early. All right, so the same thing, fixed price, lump sum, we're still talking about the same thing, right? So fixed price with economic price adjustments. A special provision allowing for predefined final adjustments to the contract price due to change conditions such as inflation or cost increases like cost of money. For specific commodities, maybe the lumber's going up and we have that worked into it. I'm going to give you a fixed price, but we'll adjust it for the price of gas. We'll adjust it for other things too. Or could be some other financial index, and it could be like price. And when we talk about index, we're talking about a combination of things. So it could be price of lumber, price of gas, and percentage rate for the money. So we put some kind of index together so that we can say, if these things go up, this is how much more of a adjustment you'll have. This would be really good if it's, if the buyer and seller, this would be if it was a long-term project, so long periods of time, like going over years. You can imagine that we're putting together a 5-year contract to provide me 2x4s. Well, 2x4s will fluctuate over the years. And so I'm going to pay you so much plus an adjustment of some kind. All right, now, fixed price makes sense so far? It's not pretty and it's not comfortable. This stuff is really easy for some people, but some people, this is the hard part. So cost reimbursable contracts, where the builder or the buyer, I'm thinking building now, where the buyer reimburses the seller for all legitimate actual costs plus a fee, which includes the seller's profit. Now the buyer risk is higher here. So now we're going to give you reimbursement for legitimate actual costs plus a fee, which includes your profit. So we're going to say, we're going to pay for, well, anyway, there's different ways to do that. So cost plus fixed fee is the buyer pays the cost plus a fixed fee. The fixed fee is usually calculated as a percentage of the initial estimated project cost. So now we're going to do, you're going to deliver the lumber, and I'm going to pay all the costs for you delivering the lumber, everything to get it here. And we're going to give you a fee of a fixed fee. And so that's where you take a little bit of the risk because your fee is fixed, right? So if you calculated it to do, provide all this lumber and you have one truck driver and one loader, that ride together or something like that. And then you find out that, well, this is really a bigger deal, then you took a little bit of the risk. Your expenses for the lumber and the driver and everything else may go up, and we may pay for the expense of the additional person, but you're not getting any more fee on top of that. So we're paying all your costs, but we're still giving you a fixed fee. So you may be doing twice the amount of work you thought you're going to do, but you still have the same amount of fee. You're not out the cost.
Hey, Craig.
Yeah.
There's another element of risk that the buyer assumes in a cost reimbursable subcontract, and that's related to the end product. So in a cost reimbursable subcontract, there's no guarantee that you're going to get what you want. It's best efforts. So in effect, the vendor can spend all of your money and you still not get what you wanted in the end.
Yeah, that's a good point. So they can spend all your budget, and depending on how they charge you, you may be out of budget, but you also can calculate that to some degree too, like we're going to pay you a certain amount over a period of time, but they could, you're right. There's a little bit of quality and timing associated with everything too that have higher risk along with the budget. So cost plus award fee. So the seller is reimbursed for the legitimate cost, but the majority of the fee is only earned based on the satisfaction of certain subjective performance criteria defined and incorporated into the contract. I don't know why I have these spelled with 2 E's all the way through this thing, but it sounds very King Jamesy. Let's see. Cost plus award fee. So do these make sense to everybody, or do we need to talk? And if anybody else has something else they want to add, they're welcome to, like Mia. So the risk to the buyer is all kinds of places. All right, now here's another one of cost reimbursable contracts. Same deal up here, same wording. Cost plus an incentive fee. Incentives for good quality or timely completion can be provided as a bonus, or if actual cost is less or more than the original target cost, both the buyer and the seller share the savings or overruns. That's an example of that. So if it looks like, well, we're way ahead of schedule, it cost us half the amount we thought it would be. We have a bonus associated with that. Maybe our fee was based on monthly, and we cut off a month, but we're still willing to give that extra month because they perform so well. And so what we're going to do is we're going to split that savings in some way. That's one way to do it. Cost plus incentive fee. So there's a maximum fee. We're going to give you, well, this is a little bit different. There's sometimes a maximum fee and the minimum fee. The minimum fee to the seller can be received. This is the least you're going to get, but if you do a really good job, this is what you'll get, but we're not going to go over that, that type of thing. All right, so now we're going to do some calculations. So when we talk about cost plus incentive fee, these are the terminologies. There's the target cost, that's TC. That's the predicted cost only of the contracted work and specific to the contract. And then there's the target fee. That's the predicted. Now this is important. Target is an estimate, right? Incentive fee to be paid to the seller, and it's specified in the contract. And then we have a target price, which is a calculation. It's the predicted overall price of the contract. So that formula looks something like this. Target price equals target cost plus target fee. So let's pretend like we have $100,000. That's our target cost. We're gonna add 10% of a fee on top of that. So that's $110,000, right? So our target price is $110,000. Did that make sense? That's a pretty simple one, right? All right, let's try again. So the next one is cost plus incentive fee. And let's see. Yeah, so the acronym there is wrong. Sometimes I copied the page, so that should be IF. So target cost, remember what that is, right? Target fee, so same thing we talked about before. Sharing ratio, the ratio at which extra costs or savings will be distributed between the buyer and seller. You see that? The buyer has a higher percentage. In this case, its example maybe 60-40 sharing ratio. So there's a buyer shared ratio, seller shared ratio. I'm highlighting the things we'll need. Actual cost, actual amount spent by seller for doing the work, determined when it's determined in the contract. And then so the actual fee, so this is how much we're actually going to give the seller. The seller's actual incentive fee determined in the contract, so when we complete it. So let's calculate that. So we said this was $100,000. This was 10% of that. And then anything we save is going to be split 60-40. The actual cost is going to be, let's say that is, so I hope you guys are writing this down. Write this down. $100,000, $10,000. We're going to give them 40%. Our actual cost, let's make up one. Our actual cost is $120,000. All right. So now calculate that and tell me what you get. I don't have it calculated in front of me. So that's 100, 10, 40, and 120. And if this was really good, maybe the actual cost would be $90,000. And so that would be another one. So calculate one with 120 and one with 90. Tell me what you get. And hopefully if I wrote that down correct, it'll be good. This is a cost plus incentive fee. And if we were to, let me get that fixed. Anybody want to share? Anybody seen this type of contract before? I mean, there's probably 3 of you that might. And like I said, this is what you need to know, but a lot of this is done outside. This is what you need to know to pass the PMP, right? But a lot of this is done outside of what the project manager does. Mia, it looks like you've seen this before.
CNS has aspects of this in their contract with the government.
So I'm not going to put you on spot with what the calculations are. Maybe I should. So anybody calculate it? The 2 scenarios? Anyway, this is pretty straightforward. It's just that it's hard to remember, right? And so, you know, this part over here throws you off. So you may see 4 different answers, and they're all going to look like they're correct, you know, unless you actually put the numbers in correctly, and then you'll get one answer. Maybe off by a decimal place, maybe off by, you know, things like that. All right, so now this is cost reimbursement contract, same thing up here, still same subject, right? So this is cost plus incentive fee. Did I just go over that? All right. Cost plus incentive fee. All right, so this is different for some. All right, so this is where the buyer is. This is calculated from the buyer's point of view, right? So target cost plus total price, what we're expecting, total price, shared ratio, same thing. On this time, we're looking at the buyer's side, and the selling price, so the maximum fee that the seller can receive, contract price, which will be paid by the buyer. So any amount above the selling price will be paid for by the seller. So even though the buyer is at risk, higher risk with this contract, the seller also has some risk. Point of total assumption. So this is a portion of the actual cost incurred by the buyer when the contract reaches or exceeds the selling price up here. Any amount above the selling price will be paid for by the seller. So the point of total assumption equals the selling price minus the total price. So this is what this is not the estimate, right? This is what actually happened. And then this is the percent, so that's 60% that the buyer shares plus the total, the targeted cost. So this is what is in our contract. So, I mean, that gets a little more complicated, right? So if we were to add total cost, let's see, our target cost was $100,000. If we said that our total price to be let's say 120, right? And we have an incentive fee. This time we're not adding a fee in here. We're just going to look at the percent we're going to share, right? So that's the BSR is the buyer sharing ratio part. And then the selling price, what we agreed to, maybe the targeted cost was $100,000. The total price was 120. Maybe our ceiling was 130. Okay. And then to calculate it, that's where the difference is. Maybe this was what we targeted, and we said, well, we're not going to penalize you until you're 130. It went to 120, and we might have said that because the project was large and complicated. So in that case, there's not a whole lot of penalty because our selling price is higher. Okay. If our selling price was the same as our targeted cost, to us, then things change a little bit. Okay. And so now if our targeted cost was 100,000 and our total price after everything was said and done was 20,000, that's $80,000 difference, right? And then our selling price was 110 because we thought it was going to take 100, but because these guys are so good at what they did, it came way below, then they have a lot to share in, right? All right, so now we're still in cost reimbursement contracts, same words up here, cost plus percentage of cost. And the fee is a percentage of the actual cost. Often illegal in some industries and countries because it encourages the seller to increase the cost for the buyer in order to maximize profit. So in this case, we could say, we got a contract with the government to provide this for $100,000, but if you can show us that it costs much more than that, then we'll split the difference. And that's what that kind of says is illegal. It's not designed to do that, but that's how it could be misused. All right, and then the simpler one is time and material. So the rate to be paid is known, but the time required is not fixed. This is a hybrid contract, and it's sometimes based on labor hours. So I'll give you all your expenses for your material, plus I'll pay you $200 an hour, and I just need you to come in and finish this work, and I don't know how long it's going to take. It may take a week or it may take a month, but I'm going to pay you for your time. Guaranteed maximum share savings. And then this is a feature that can be incorporated in certain contracts. The seller is reimbursed for costs up to predetermined selling price. Remember what selling price is. And it's also paid a fixed fee for the profit. So we're guaranteed that the maximum, and the seller is responsible for the cost overruns. So as long as this is our selling price, we're going to give you this fee. If it goes over, it goes over. It's not our problem. However, savings are shared between the buyer and seller. So if you, for example, and you can have also the overrun shared, but you could also have, so if you make a lot, if you do this really well and this selling price is here and we're going to give you this fee, you get to keep the whole fee. The fee might be based on a monthly basis, so you get the full fee, some incentive. And then we have bonus and penalty and any combinations. And then we do things in joint ventures that change it a little bit. So here is, let's see, we got 5 minutes left. So I'm thinking that the rest of it is terminology, and I have that in your on your PowerPoints, so you can read the rest of it. And I think that you've gone through the hardest parts. Well, maybe the change is something that this is probably one of the last slides. So this is when you're controlling it, then you got to really control change and construction and all the other things. So you got to just make sure that the change controls are there. And then there's also ways to look at the changes, and there's change forms and other things too. But the rest of it is in your PowerPoints, and I think that we've gone through the hardest parts. This might be contractor fails is a good thing to go over, But to make delivery on scheduled dates, that could be a way fail. To make progress so as to endanger performance of the contractor, in other words, going too slow or terms of contractor or even subcontractors, and to look at other provisions. And just, I must have done a search and replace, and it must have kept the E at the end. So disregard that. But I think that's it. We went over most of it, and I don't want you guys to have to go too much longer. But this part's a very complicated part. It's usually involved with legal and with senior people in the company, and the project manager doesn't always get involved. But in order to pass the test, the PMP, just look at those different types of contracts and do some of the calculations, and then I think you'll be pretty set. Read over the rest of it. The terms are important, but they're pretty straightforward. They're just definitions, and you can look at that on your own. But anyway, that's it. I thought I'd take less time than this, but we spent a little bit more time talking about it. All right, so that's it, and I'll see you guys next week. Sorry I took a little longer. I think that next time I'll try to give you a little more break. See ya. Bye, Rob. Bye, everybody. Bye, Tim.
Hi, Craig.
See ya. Bye, Roy.
Bye, Craig. Thank you.
Bye, Blake. All right.
Hello, everybody. How are you?
Hello, Dr. Nathan.
Did you finish the previous class long ago or just coming back?
We just finished.
All right. So I'll give you 5. Are you guys able to see the PowerPoint slides for today's lecture? All right. By the way, I tried to respond to most of you who had questions in the quiz. I made a mistake with more than one question. So I already reviewed and corrected for those of you who had the correct answer. So we should be up to date with the reviews and any grade modifications.
On behalf of Team 3 and in light of the current situation going on in our country, I think I should let all the other teams know that the simulation is being counted correctly. There will be no need for a recount at the end.
I don't know what you meant.
Last time we checked, we were kicking it.
Enrique, this was such a hard simulation. Everyone who's positive at the end should get the 10 points. If you've made any money at all and not lost $1 million.
Well, that's the difference.
terrible.
It includes debt.
We're just waiting on the other shoe to drop, like, you know, a machine's gonna fail unexpectedly, or act of God, or something's gonna come and mess things up for us.
So from the first simulation to this simulation, did you see the progression in the level of difficulty?
The first two simulations are a lot easier than this one.
Right.
Royce, is that just accrued interest at this point, or are you taking out more loans to try to get positive?
No, I'm telling you, this is the most difficult one to get your arms wrapped around. And we swung for the fences to try to overcome not being engaged on day 51.
So how many loans have you taken out at this point?
That's confidential information. I cannot provide that information to you.
All right, that's fine. It's too bad it maxes out at contract 3, and once you're there, it just kind of holds steady.
Yeah, I've learned the tricks of the trade, but this simulation, there is no tricks to the trade. We'll document that in our report.
All right. Okay, guys. So today's the second to last lecture. So I'm gonna be brief in today's presentation. I'm hoping to get at least half an hour earlier today. What we're gonna do is we're gonna go through this topic, distribution requirements. So we already went through the entire MPC system from the internal standpoint. So now we're gonna see how it connects to the customers and the external environment. And the next topic will be the strategies, which is next week. And I promised you that we were gonna do some of the R. So for next week, please have the access to either that you installed the interface in your computer, or just be ready before the lecture with the R platform that you can access through apps.utk.edu. In any case, if we run out of time next lecture to talk about R, then I'm gonna record a video explaining the basics of R and how it could be used for the topics that we covered this semester. So that being said, quiz number 4 is going to be active after today's lecture. All right. And you're going to have, like last time, 2 weekends. So you're going to have this weekend and next weekend. It's due on, what is it? Monday, I believe it's 23rd. Yeah. So right before Thanksgiving. Our last lecture is going to be next week. So we will include in the quiz the topics that we cover. We covered 2 topics last lecture and today's lecture. And differently from the other quizzes that we have done, this time you're going to get, the distribution is the following. So 3 questions of the first topic, which is advanced scheduling, 4 questions about just-in-time, and 3 questions about today's topic. So that makes up the 10. Because the just-in-time is 4 questions, I have not designed this to have exclusively one problem. You may get 1 problem, 2 problems, or none. But these problems are super easy, all right? So pretty much you need a calculator or an Excel spreadsheet, and it shouldn't take you more than 1 minute to get the result. All right. So the like before, if you need any formulas are provided there. So you just need to make the calculation and that's it. Okay, 15 minutes, same 10 questions, and it will be active after we're done with today's lecture, hopefully half an hour earlier.
Will you repeat the 3 topics again, please?
Yeah, it's the whatever we covered last week, which is advanced scheduling and just-in-time. So you just use the slide set of last lecture and today's distribution requirements planning.
Thank you.
All right. So for today, we're going to be looking at just a very general overview of the distribution requirements planning. Similarly, as we have talked about the capacity requirements and the material requirements, we're going to end up the semester with how you connect all of that planning in the manufacturing planning and control system with the external environment. So we're going to go through that and the techniques, some management issues, and the principles as usual. All right. So the acronym for this activity is DRP, and it's pretty much the integration that you have with distribution activities. So this is where you do actually make the analysis of how this connects with the system of finished goods, right? Warehousing. How do you break up your finished goods or spare parts or any other configuration that you want to have to deliver to customers? And the concept of connecting with vendors. All right. So basically, the DRP system connects at 2 ends. So this could be kind of a feedback loop where you have the connection both at the front end and the back end. So it goes in different ways. And I'm going to show you with the traditional chart that we have seen about the MPC system. So basically, we get through this into trying to integrate the supply chain, all right? And we're gonna be using the distribution planning records as the main tool to be utilized into this connection. And we use this exercise as I mentioned, in both ends, so that we connect with customers, suppliers, and the entire streamline of the operations from an ERP standpoint. So this is the MPC system as we have covered. So we started going from the macro level, which is the sales and operations planning, demand management, resource planning, deriving into the MPS. The connection at this level is particularly on this end, the demand management. Let me just bring, not the pendle laser. So we connect with the demand management as to for how are we going to understand what is needed. So this counts to say, well, these are the requirements and this is how much we need to start planning for so that we can define the master production schedule. Then this goes through the entire streamline as we did the capacity requirements planning, the material requirements planning, and then that derives into the plans, which in itself connects to all the the back end, which is the shop floor scheduling, the quality systems, and the vendor systems. So we addressed these two in the last lecture, and the two lectures from today, actually, the production activity control. So here's where we come back and use the vendor systems as the other source that connects to the distribution. So you see how it connects at both ends. So the system pretty much goes into this connection that has an interface externally with the customers, but internally it's this stream over here. So it's constant feedback between demand management and distribution requirements planning, internally to define the logistics systems, and we're going to talk about that later. But all of these has to match and tie up with the master production schedule, right? So you can see here that we have these connections that are internal and external, right? So this connects directly with customers. On the other end, we're going to be connecting the vendor systems that we design externally with the distribution requirements and with vendors by themselves. So, and this particular end is more stressed when we address the design of a system with vendor managed inventories. If you remember, we mentioned this before. The vendor managed inventories are pretty much, they're very common from in a just-in-time design, but it's pretty much when you have the inventory at the facility when you pretty much pay for what you retrieve from the shelf, right? So it's considered to be external connection because that vendor managed inventory is still depending on the supplier. So the supplier controls how much he's going to have in that location. I can only share the demand. I can design a Kanban system, if you may, but the only thing that I, as the user, and from the standpoint of me controlling this entire system right here, the only thing that I can control over here is the retrieval of the materials. I pay for them only when I use them, right? I can share as much information as possible with the supplier, but it's the decision of the supplier to decide how much he's going to have. Of course, it's obvious that for this type of system, when you have vendor managed inventories, your connection with your supplier is much higher. So he should have access to your ERP system. He should have access to your forecasting. The planning is a little bit more tight, and the system in itself, it's promoting, as we covered last lecture, that joint facility just in time, or joint firm just in time, where you have a little bit more exclusivity with the type of vendor in this kind of system. And you have as well pretty good stability, so that the vendor does not get caught with surprises in pretty much back ordering something that you retrieve from his controlled inventory. So it goes at both ends, and basically the distribution requirements planning, from this standpoint, it connects the internal system with the external systems. All right, so that's the main connection. Both ends, and it circulates in the internal planning, but also in this other type of system. It connects directly with the vendor managed systems. All right, so the distribution requirements planning, it's the one that is going to control how to move things at the end of finished goods, so that we can plan for whatever needs to happen in my facility, right? So physical distribution system is the main role of the DRP. And how you're gonna get it, where are you gonna get it, all these type of things, that's part of this role. So these inventories are replenished with timings and quantities. So this goes along with forecasting. This goes along with fluctuations in the market demand, so that we know that we saw that once we start from the master production schedule, there's a certain level of flexibility, especially when the horizon, the planning horizon is wider. As we get into the production activity control, the flexibility is reduced, and there's not so much that we can do to change that, because at that level, when we are dealing at the bottom, production activity control, this area, when we're dealing at this level on the back end, all we have to do is to move things so that we can keep retrieving for the orders that were promised, or for deliveries that were already committed. All right. So all these dynamics are going to feed the master production schedule, and every piece of information that is used into the distribution requirements planning has to be in the same language that is used at the records that we'll cover when the material requirements planning. The main reason for that is because the distribution requirements planning is going to be the method of motion for these materials. So it has to speak the same language with the same level of aggregation, and it has to be easy to retrieve so that we can circulate this information as needed throughout the system. All right. So from a distribution standpoint, this is where we actually make the execution of the transaction, right? So this is where we have something tangible that we need to take to whoever we are selling. So we already went through an entire process of forecasting the demand, understanding what are the capacities, requirements, the material requirements, and all that stuff. So we went through this breakdown and through this funnel, and until we reach the execution point. So with here, the distribution requirements, it deals into not only how much are we going to move, it's how we're going to move this basic the product. All right. And this is where we start with the back and forth and the negotiation onto what is actually going to be executed. All right. So we have mentioned of those fluctuations and how the fluctuations in a planning level and then at the execution level at the shop floor can affect the entire system. Here, where we are dealing with is that it's going to take an entire cycle to go through the entire planning process if we have to manage some of these fluctuations. So here is where we, if you remember, we were addressing for special orders, expedited orders, things like that. This is where we get the information from, because we're literally retrieving from the shelf. So whatever I have that I can send, we're taking from here. And if there's something that is with a higher need or higher priority besides the traditional or the expected lead time into the planning process, then we need to make adjustments to the master production schedule at this level. So from the demand management, the top of the MPC system, the design into the information from, this is an internal standpoint. So we're leaving for a moment the customers aside, but this is still managed internally. So here's where we need to decide how what are the quantities of resources that we're going to need in order to distribute and deliver our product. So that goes along into deciding these very key things of in the supply chain, which is the vehicle capacity. So we need to decide the fleet. We need to decide the loading of the fleet. We need to decide how are they going to be circulated. So when, how, to what points, who's going to do what, and how are we going to control all the incoming as well. So this, in essence, is really important because there was actually, we didn't get the contract for this project. I don't know if I shared this this opportunity with you, but we were talking to one of, it's a distributor for, they call they use a funny expression, the grandpa and grandma's, what is it, warehouse store. So they basically distribute hardware to small shops all over the country. And one of their issues is that they had, they gained a contract, they acquired somebody, another distribution company that granted them access to go through, include, I think it was Louisiana, Texas, and Oklahoma. And the problem they were having was pretty much into handling this because they were having issues into how do they design the runs in delivering the product. For a distribution company, the key is into how much product I want to bring into my shop, into my warehouse, and how long am I going to allow it to stay there based on forecasting, pretty much. And one of the things that they were doing here is they were trying to optimize if the supplier was closer to the point of use, so they were not going to bring it to the warehouse here in Knoxville. They were just going to pick it up and take it to whatever the point of use was. But you can think of that as having several complications, just like you have a truckload already of distributed products. So that means that if you plan to pick up something, then you need to leave that space in your truckload so that you know that you're going to be able to transport that. Now, the second issue was, well, if you pick everything from a specific vendor, then that truck is allocated to distribute that product within that region for everybody. So in the fleet management, one of the biggest problems that I have seen that, I mean, there are efforts in trying to optimize is how do you keep utilizing your truckload capacity at the entire route, at the extent of the entire route, because once you get through a route and you deliver, you have to come back to the distribution center, right? You have to come back to the depot. So there's what they call empty miles, if you may, where you're still spending time, you're still using the equipment, the trucks. So there's a wear out process there, but you're not adding value to the business except for the fact that you're returning to the starting point. So all of these concepts are controlled internally. You may use the information from the customer standpoint, but you can see that how this connects at the top. So all this information has to be connected again with the master production schedule, because that's exactly how we're going to trigger again, and we're going to understand, well, we need to produce this much, but there's no point to produce if we're not going to have the means to move it, right? And a lot of times the synchronization between these elements it can be very costly. So from that standpoint, all of this information, we said that we were going to be talking the same language as in the material requirements planning. So that's how you connect this to the master production schedule. So you get a good glimpse into the entire threshold of the life cycle of that product within your facility. So that's one of the first advantages. Second, it depends into how well you're related with your customers and suppliers, so that the information is something that is valuable throughout the entire supply chain. Achieving that, as it mentions here, can be very costly from a political standpoint. It all depends on how well you develop the relationship and how much trust have you built within that connection. As I have mentioned before, in automotive industry, or in pretty much fast-paced environments where the inventories have to circulate a little faster, the one that is dictating the pace in automotive, the assemblers, in electronics, so well, the brands, they try to establish a very, very good connection with all their suppliers. That's why, depending on the business that you're dealing with, there's this new opportunity for companies that pretty much handle the entire supply chain because of information integration. All right. So that's business in itself. So what comes back from for the master production schedule is, well, as you are delivering and you have the closest connection to the market, everything is coming back. That's how pretty much everything gets triggered, and this goes from both ends. This goes from the demand planning, but also with the vendor systems. All right. So before we move on to the next topic, it's 2:02. Let's have the 5-minute break. All right, we can continue. One classical application that I was going to mention of operational research methods is precisely the transportation method to decide if we have certain locations that are the supplying warehouses, and then we have specific points of distribution requirements, so the market. We can design the matrix, the from-to chart, and apply the cost by distance and usage of gas, or you can define a standard unit of cost for each mile traveled, and make a decision into what's the optimal quantity that you are going to send from each supplying warehouse to the market. So that's a very typical OR problem in supply chain. So, okay, from the techniques that you use in the demand requirement planning, a lot of this is similar to the other planning stages, the capacity and the materials. But the essential part here is going to be this one right here, the records. And as we mentioned before, these look very similar to what we have used in the MRP and the capacity requirements. These type of records have one small difference to the other ones that we have used. The other records, from a bill of materials standpoint, we were pretty much considering the units that have to be from a raw material standpoint at each one of the work centers to be produced. In here, we're gonna start using the concept of the SKUs. I know that for somebody that has been working in supply chains, this is a very basic unit, the SKUs, the stock keeping units. The meaning of the stock keeping unit is what makes the difference against the MRP records. The stock keeping unit is going to be considered complete only after the delivery where the product has to be supplied. So that means if we have to combine different orders or different levels into an SKU, or there's a specific order, from a bill of materials standpoint, if you can make the metaphor, the level 0 where you complete the SKU is going to be when you have delivered the product where it's demanded. This could change depending on the contract, all right? So we can have contracts that are to be delivered at the point of use, or we can have like vendor managed inventories that, we're going to just put it in the dock and the customer is responsible for taking it from our facility. So that's very contractual based. So that's something that it's has to be analyzed from the overall strategy of the organization and working together with the finance department. But the SKU counts at the moment that it's being touched by your customer. All right. So basically, that's the unit that we're going to be using. And in here, we're looking at the example of a single SKU. All right. So these are the periods that you're going to have. These are the requirements. And one of the basic elements that we're going to be using again in here for the records of the distribution requirements is going to be the forecasting. Okay. So forecasting is the number one thing that we're going to be using throughout the entire planning system. But see, the level of aggregation here could change. Why could it change? Because we could have this, we're showing here just a single SKU, but I'm going to show you in the next technique. We could have from multiple warehouses the information to deliver to a single SKU, right? So that's the part. So the SKU is defined with the delivery, with when the customer has touched it, all right? So we get to see the similar format on the record where we have the forecast here. So this is the demand, predicted demand for each one of the periods. This is how much we're going to have in transit at that period. So this is the projected available balance, all right? Do you remember this is when we are having the material coming to a specific design point? So we have 45 at the beginning, and then this is the projected that we're going to have 25, and then we go here. So plus this 60, we're going to have 65. 65 minus 20, we get 45. 45 minus 20, 25. 25 minus 30 is going to be minus 5, but because we have planned shipments over here, then it gets to 55. So you get to see over here that basically our safety stock is at 20 is using the same information that we used in the master production schedule, in the material requirements planning, capacity requirements planning. So same level of information, same format for the record. You just have to consider that the number here is an SKU, which means that's what is going to be given or delivered to fulfill the demand of the customer, right? Another technique that is used into the demand requirements, distribution requirements, is the time-phased order point, all right? So this is where, based on the record that we used there, we're going to have to be allocating according to the forecast all the material requirements for the shipments that we are going to have to fulfill. All right. So over there, as you could see, we include planned shipments. So that has to be part of this record. And all demand sources are considered into this particular planning point. So time-phased order point means we're going to have to send something 2 or 3 periods down the road. The service parts, this is very important because especially when you are in a facility that is working with a finished product, you have to allocate internal resources for service parts as well. In automotive, I remember very well, like the entire just-in-time system. I'm going to tell you the example that comes to my mind right now. This is a Nissan facility. So they had a small unit of plastic injection. So they were doing the injection and painting of the front and rear fence for their cars. So this was done internally. It was not subcontracted. So once they have the bumpers, so the front and back rear bumper, they basically had to integrate that with the assembly so that it could go into this just-in-time logic for the paint shop. Because remember that I explained before, in a paint shop, you have to put it all together so that it comes into that painting process and then comes out, and then it's split again to wherever they have to go. If you have seen that process, you know what I'm talking about. So the only reason to come into the paint shop at the same time is that it has exactly the same color. But one of the things that was not considered here is that, well, what was one of the parts that is more commonly demanded for service parts when you have an accident? Bumpers, right? So how do you make that synchronization of the service parts into the just-in-time system? Because everything is done to the order. Obviously, you can build bumpers much faster than you can assemble cars. So they use that extra time to include these service parts. And if some point, if you had to include, let's just say for the sake of the example, that you schedule as a service part a white bumper, both rear and front, and maybe you needed 3. So you included that into the batch of the white car, so that the white car comes in with the bumpers that it's gonna have, plus these 2 additional that are gonna be considered service parts. Obviously, the distribution points and the warehouse for the bumpers, I mean, these bumpers are gonna be installed into the car eventually, into that complex conveyor system. So it's gonna come through a different delivery point, where the other 2 white that were assigned as service parts are gonna be allocated. And they may not even go to the same distributor. So that's one thing to consider. Another thing is, like, do you remember when I told you about the example with TVA, that they were trying to, they were managing inventories individually, but they wanted to get shared parts. That's also as well some part of this whole distribution requirements planning. You have to account for how you're going to move things between facilities, and that's one of the things that they're actually doing at TVA. They have to use a fleet vehicle to move things when another plant or another power generating plant is needing something that they don't have on hand. And the question in that is, when is it cheaper to retrieve it from internal use, or to just buy it with the vendor that is closer and you don't have to wait for it. So there's a threshold there that you need to consider into the transportation, into the availability of the parts, and all this sort of thing. So all of that has to be included into this time-phased order. Here's where the other part that we mentioned initially. This is the type of information that we use when we're dealing with this classical OR problem. So in here, you remember that we said the level of aggregation when we're starting in the front end, it's at a much higher level. You could go by a certain unit that is standard throughout different product families, even products that do not look alike each other at all. The phenomenon at this level, it goes backwards. So when you're dealing with this type of distribution, you're going to have materials that are in different locations, and they're going to have orders that require multiple different materials and that could go to different markets. So over here is where we call this, you remember that we had in the bill of materials, we called it explosion when we wanted to know the detailed level of raw materials that we are going to have from a specific finished product. So over here, we're doing the inverse, but it's just because things are in different locations. So we're doing an implosion, all right? So this implosion process is just to centralize the availability of items that we have in different locations. So for a particular SKU, as we have mentioned, so these are gonna be the information requirements that we have in different places. So this is particularly useful because as we have in the common sense in supply chains, you have one factory for multiple warehouses for even more distribution centers. So where do you need the items according to your forecast at any given point? You just centralize that information before the distribution. So that's how you translate this. Remember, we said we were going to have to speak the same language as the MRP. So this is how it comes back, because you're going to try to produce everything in a single location. So from a master production schedule standpoint, I need to know the requirements that are forecasted at each one of the distribution places into a single unit. All right. So this is exactly the same format that we were looking at before, but this goes for the distribution requirements. So one of the things that we have addressed in all these planning, again, I probably have said this more than 100 times now, from the front end to the back end, the flexibility gets reduced. Now, we're dealing with a system that is connected to both ends of my organization. So how do we deal with this variation? How do we address the flexibility on changes that we need to make through the plan? Well, as you remember, when we are at the aggregate level, when we are dealing with demand management, the planning horizon is much larger. So we have a lot more flexibility to make adjustments into that, right? But as we go through the production activity control, all these changes just create chaos. And we define that at a certain point, we can design that freezing period that where we're not absolutely going to make drastic changes to what we're supposed to do. So the two strategies that you use in distribution requirements are the firm planned orders, all right? That's pretty much what cannot change. And then there is this one that is, this is new, we haven't covered before, is the error add-back method, all right? In order for this error add-back method to work, first, the most important assumption that we need to have is that all forecasts are unbiased. You remember that we had these methods to measure problems with forecasting, right? We measured the mean absolute percent error, we measured the tracking, we measured the bias. So as you're doing the forecast, you have to check that it's actually unbiased, all right? If the forecasts are unbiased, then we can utilize the shortages from one period to be made up in the next, all right? So that's the error add-back. Whatever happened that was missed, because we already reached the execution point and forecast said that we had this level and we missed by 2 or 3. So that's gonna be made up in the following period, right? If we did the opposite, that we over forecasted and we have to keep something in inventory, we use that adjustment to be reduced in the future, all right? So this is a very simple technique. We just move things as we are missing in the immediate next period, all right? If we have forecast bias, this add-back method becomes very painful. The reason why is because you're constantly going to have fluctuations, all right? So the safety stock, I guess this is the most simple concept to explain. We already have that safety stock is sometimes, or by rule of thumb, the 10%, or there's the probabilistic methods to calculate it, right? Depending on the service level that we want to keep. But when we integrate this into the demand requirements planning, it means that that safety stock is not going to be only at the facility level or from a production standpoint. It also is something that we can keep at any of the subsequent locations that we're going to have for the distribution. All right. So from a lean standpoint, we understand that the increase in the frequency of replenishment is going to be inversely proportional to the need of a safety stock, right? The reason why, because we can react much faster to the delivery of the materials. All right, and as you remember, when from factory physics, we can use the same principles. Instead of looking at it from a single line, we can use this from multiple locations, that we can do the variability pooling, right? So that we distribute the risks along the different points in the supply chain. All right, so we finished slightly faster. Let's go into the 5-minute break. Let's come back at 2:33 before we jump into this topic. All right, you can pause the recording. All right. Any questions so far? Okay, let's continue. So from the issue standpoint, we have three big areas, which are the data integrity and completeness, organizational support, and problem solving. In the data integrity and completeness, we have talked about this in the other lectures, which is this concept of garbage in, garbage out. I heard it from my simulation professor in my PhD, and I guess that applies to everything. So two things that become very, very important into this it's not only of this distribution stage, it's also part of the entire system, is the forecasting method, the accuracy of forecasts, and second is the accuracy of inventories. So for any issues we have into each of these two elements, it could complicate the design of the requirements that we need for distribution, right? One of the things that is very common to find is that as we go into the level of disaggregation, and if we have a certain level of error into the forecasting, that disaggregation is just amplifying the error for the forecast. That's the reason why, and I'm going to make a parenthesis here just to illustrate the example. That's the reason why when you, if you check the weather and you check what's the forecast for the next few hours, and then if you check what's the forecast for the weekend, and if you check what's the forecast for the entire week, you're not going to see that in some cases the forecast match, because there are different techniques that are used to overcompensate this particular problem, right? When you break down the forecast of a day into hours, it's not that just divide and disaggregate. You have to pretty much adjust a different model to forecast by the hour based on the information that you got for the day. So that disaggregation has to be addressed differently. So the forecast adjustments have to be part of the exercise in making sure that it's a useful tool, all right? And remember, forecasting has to be usually considered carefully, as depending on the method we use and depending the planning horizon, the precision of a forecast gets reduced as we go farther into the planning horizon, right? So that's the one part. The second, inventories. And we have mentioned this over and over again through the entire semester. The accuracy on the inventory count for both work in process, finished goods, material in transit, and so on and so forth, has to be as accurate as possible so that we can pretty much execute according to the plans. And I guess this is very easy to mention, very easy to say, but it's the most sensitive point and the part of dissatisfaction mostly with ERP systems in general. So ERP systems are very helpful on a macro level and from a financial standpoint, but I guess in my personal experience, most people that deal with the daily production tasks hate the ERP systems. From an organizational standpoint, the conflicting, you remember we talked about when we are sub-optimizing from a silo standpoint, is no exception for the distribution requirements that if we want to optimize a certain part of the business with a very specific objective, is going to affect the I would consider the most important metrics that we have from a customer standpoint. So we measure everything in throughput, but at the end of the day, business, if we remember, with cycle times being associated directly with customer service and being able to deliver on time, as well as inventories, they get affected as we sub-optimize different objectives. So in this case, to prevent confusion, I was going to say the green doesn't mean that it's good. It just means higher. Okay, so the arrow pointing up means higher, and the red pointing down means lower. Okay, it doesn't mean it's good or bad. So if we pretty much want to achieve higher customer service, we're gonna pay by increasing inventory and the total costs. All right, so that's, I mean, it's a decisions of strategy, but it could create conflict if there is an objective of the finance department or production to decrease total costs simultaneously as increasing customer service for the logistics department. So logistics department and production are going to be in constant fights, which happens. Same thing here. If logistics, the fleet management has the obligation of reducing transportation costs, that directly derives in increased inventory and decreasing customer service. Indeed, we're going to decrease the total costs, but at the expense of these other two. If we want to reduce warehousing costs, we may reduce inventory, but at the cost of reducing also customer service. So you see, it is almost impossible to have a win for all, right? This is where you have to define what's the strategy of the business and what is the strategy of, or what is the role in the from an organizational standpoint of the supporting activities to the manufacturing process. So at the end of the day, you get paid by delivering products, right? But where is that point where you can say, well, this is a good customer service that I want to keep without increasing my costs too much? So how much is too much? And in that sense, I guess one consideration to have is that it totally depends on what business you're running with. For electronics, where you see it, I mean, that's the Moore's law. The pricing and the capabilities of technology duplicate. I don't know what is exactly I can't remember the Moore's law definition, but it in essence is that the cost decreases and the technology advances at a X rate. You can Google it. You pretty much see that today's flash drives have already, you can have flash drives that have terabyte capacity. And that wasn't possible 3-4 years ago, or if there was one, it costed you over $1,000. Now you can get that for $100, and the terabyte capacity in 2 years is going to be something that you can pay $10 for, and it's very fast. So in that case, probably customer service wouldn't be something that you want to sacrifice. You want to deliver as fast as possible. Inventory turns in here are crucial when you're dealing with technology. But if you have a high-end product that nobody else is producing, maybe customer service doesn't matter much, right? You want to reduce the cost and you want to maximize your profit. So it totally depends on what business you're dealing with. And from a problem-solving standpoint, you're gonna have to deal with frequent challenges. Again, this is depending on what sector you're working with, but pretty much you can have context with, again, the project that we're working with, this supplier of machine, the paper parts, paper fabrication or cardboard fabrication machines, is very interesting because we have seen pretty much a lot of the things you could imagine in the threshold of challenges. They shut down a warehouse and they subcontracted with UPS the delivery of some parts. So they're holding in inventory some of their products in the UPS hub in, where is it, Lexington, Kentucky. And they had to phase out very well how to push the product that they had in inventory, and whatever they could not deliver directly to customers, well, they had to relocate it. That has a cost in itself, right? So, and that is a function of the distribution requirements planning, because you're increasing cost into not distributing the part to the customer, but relocating from the warehouse you had it to another warehouse. Moreover, that you're subcontracting this new supplier, so they're charging you for the amount of time that they're holding your inventory. Whereas in your own warehouse, you may just have to pay the fixed cost of power and I don't know, the overhead and all those sort of things. So that's one kind of challenge that you need to incorporate here. Another one is the introduction of different products. So sometimes you may decide to send something to a particular warehouse and then it doesn't work and the market changes, demand changes, so you have to send it to a different warehouse. And these fluctuations could affect the entire logistics problem, but you need to take that into account as you plan for moving those parts. And another one is the nature of the product by itself. So the life cycle of some products, as we mentioned just before, technology, if these are technology products that you cannot move fast, they lost their value, but you already paid for the warehousing and the logistics of it. So how do you get rid? So you can stimulate by forward purchasing or some promotions. That's part of the vendor systems that have to move these products depending on what market they're in. Or it could be that the product has a particular shelf life, especially with foods. One of the businesses that started growing in Mexico a lot lately was the what is this big refrigerators? So the refrigerated warehousing, but huge places, and with all the technology that you can imagine, ASRS, and they have allocated. I remember one company did. I don't remember in square footage, but it was a huge facility, and they allocated, I think, about 60% of that space only to subcontract. 40% was only for their own use, internal use. It was a food company. The other 60% was because it was very good business to just allocate this into anybody that could use it. And they had direct contracts with Walmart, with Costco, and these sort of stores, because with the refrigerating space augmented or helped to reduce the cost of distribution for them by holding these perishable products for a longer period of time. So that's also part of the distribution requirements planning. All right, so as I mentioned before, we were gonna finish today a bit earlier, just to go over the principles into this topic of the distribution requirements planning. So main document that we're gonna be using in distribution requirements planning are the DRP records, and should cover items in a location as close to the customer as possible. For this, we're going to be using the unit of SKUs, right? And that SKU includes that we're going to have a completed SKU once it's delivered to the customer. Market information as well as demand patterns should be included as part of the forecast for the warehouse so that we can have a more accurate planning for it. And we need to integrate the system of the demand requirement, distribution requirements into the entire ERP so that we can speak the same language and have visibility for whatever is happening throughout the entire system. From a forecasting standpoint, the projections of future requirements should be used to decide inventory allocation in periods of short supply, right? So the time frame or the threshold, you don't want to allocate a product to be stored in a warehouse for a very long period of time if your cycles are much faster than what they could normally be. So if you have a product that is in a warehouse that has not moved into a defined threshold of considering obsolete, that means that you allocated the wrong product in the wrong place. As we mentioned, the accuracy of information is going to be important as we integrate throughout the system. We could use what-if analysis to understand what's going to happen to prevent any mistakes or prevent any possible scenarios. We have these techniques of firm plan orders and error add-back that could be used in order to trigger the production and compensate for anything that creates fluctuations into the demand. And this should be readily available for the master production scheduler so that it triggers the system again and circulates the system from the front end all the way to the shop floor. All right. So in essence, and this is something we mentioned when we work with the factory physics, the principles behind distribution planning and the supply chain in itself, it has been for quite some time now the focus of lean operation. The reason why lean systems or continuous improvement systems have been available for quite some time now, 40 to 50 years, if you may. So organizations and companies internally have become efficient as they get to know more about their business into how they move their resources, especially in large organizations. Some could be in some medium size, some small size as well, but in large organizations, the grasp is really good. The inefficiencies, and if you remember from the standpoint of the variation and variation of arrival, variation of processing is, as we have more technology and more tools, it's becoming less and less of a problem. The impacts are always going to be found into the non-value added element of the supply chain. The moving of the parts, the weighting of the parts, the storage of the parts. And this is where right now most of the focus is across the entire field of supply chain, making supply chains leaner. That's where the big dollars are in savings, all right? So that concludes today's topic. Just to go back, we have gone through the entire MPC system and we connected most of the things that we did into the MPC were categorized as internal to the organization. So we went from the things that are more at the macro level, where you use aggregates, the larger horizon and the planning for the forecasting, and how do you define what you're going to need, and how do you find your installed capacity. It could include logistical decisions as for where to put your facilities, how much are you going to allocate to that facility to produce, so on and so forth. That goes into the front end. And then as we move through the engine includes the ERP systems and the MRP systems. So ERP is connected throughout the entire system, but material requirements planning goes here, and we have the capacity requirements planning as well. That connects into having the documents of the plans of what we're going to need, both in the human resources and materials. And this is what connects directly. It's the breakdown as we go down through this path to the shop floor. So here we connect both the shop floor activities as with our warehousing, where we have finished products, so that we connect with the external environment, with customers and vendors through vendor managed systems. So, right. So the entire distribution requirements planning serves as the connection between the internal system, the MPC internal system, with the external world, the external environment, right? So as we went through the entire semester with this, that's how we conclude the entire analysis of production and inventory management. The last lecture is going to be about strategies. So what strategies can we use now that we have broken down the entire elements of the MPC system? So what strategies do we use into what contexts? All right. Okay, guys. Any final questions, comments? If nothing, then if you want to go ahead and take the quiz today, your quiz should be available in 4 minutes. All right. So you can start taking the quiz at 3 o'clock. It's going to include today's information as well as last week's information. This should be the easiest of all the quizzes for a simple reason. It has a lot of theory of constraints. It has a lot of lean, just in time. And well, today would be probably the only topic, but it was very easy to go through as well. Distribution requirements planning. And for the final, we're going to include whatever we cover with the strategies part. Okay. So you have from today till not this Monday, but next Monday, which is the 23rd, before midnight, to answer the quiz. All right. And this is running in parallel, as you will have an extra week to go through the report. So you're finishing the simulation next week. So you're midway through the simulation right now. So it finishes next week, and then you have an extra week, turn in the report, and it's going to be again due on Monday after you come back from Thanksgiving. So the only two remaining activities are going to be the case study and the final. All right.
Dr. Enrique, I just
Yeah.
have a quick announcement. For 536, that video is going to take a little bit of time to get uploaded. The cloud recording has to convert first. So actually 542, my bad. So yeah.
Okay.
Dr. Enrique, you said load, make sure we have R loaded. Is that the same R Studio we used before? Is there a different version?
No, that's same. Yeah. Our studio. Yeah. Any other questions? All right, guys.
Thank you.
Well, thank you, guys.